Welcome to PHP Essential Training. PHP allows writing simple code for web pages. If you've been using HTML to develop websites, PHP is a great next step. In this course, we're going to focus on learning the fundamentals of the PHP language. We will learn how to embed PHP code into an HTML page to output dynamic text. We will review the basic PHP data types, such as variables, strings, and arrays. Then we will learn about the different control structures in PHP, such as logical expressions and loops, which give us control over how our code executes. We will cover many of PHP's built-in functions, but also learn to define our own custom functions. By the end of this course, you'll have the basics you need to start adding PHP code to your web pages. Let's get started learning PHP. In order to make use of the exercise files, you'll want to first make sure that you install and configure PHP in a web server. The course, Installing Apache, MySQL, and PHP can help you to get those installed on Mac, Windows, or Linux. The exercise files are arranged by chapter and by movie. And you can find the exercise files that correspond to the movie that you're watching by first looking for the chapter number and then the movie number. You'll want to copy the contents of the exercise files into your web document root directory. On my Mac, that's going to be inside my user directory in the sites directory. It's always a good idea to make a copy of the exercise files so that you still have the original to refer back to if you make changes. I'm going to option drag the folder to create a copy. Once you have the same files and the same database, you'll be able to work right along with me. Don't forget, you can also use the exercise files to check your work as you go along. Before you can start coding in PHP, you will need to have a web server installed and configured to interpret PHP code. There's a course in this library called Installing Apache, MySQL, and PHP, which will help you to get everything you need installed on Windows, Mac, or Linux. In that course, Chapter 1 will help you to decide which software to install. Some developers prefer installing separate software components, while others prefer prepackaged software bundles like the popular WAMP server for Windows. PHP and the exercises in this course will work the same regardless of which one you decide to use. Then, chapters 2 through 6 will guide you through the installation of Apache, MySQL, and PHP for your chosen platform. Even though this course will not use a MySQL database, it is a common part of PHP development, and it's worth installing it at the start. Finally, notice that Chapter 7 will help you with troubleshooting if you run into any problems. Once everything's installed, you'll be ready to start learning PHP. We're going to start out by talking about what is PHP. PHP is a server-side scripting language. Now you may have thought that PHP was a programming language. Well, technically speaking, it's not. So how is a scripting language different from a programming language? The distinction between them is largely artificial, and the lines can get a bit blurry, but we can do a general comparison. A script only runs in response to an event. It also usually runs a set of instructions by working down the page from the start to the end. It has little or no user interaction after that initial event. So a PHP script does not run until a web page is requested. Then it launches, follows its instructions from top to bottom, and then quits until another action launches the script again. On the other hand, a program runs even when not responding to events. It continues to run and to wait for interaction, whether that interaction comes from a user making choices or from other programs or input. A program also jumps around its instructions a lot more, so that there's often not a clear start and end point. And it often involves lots of user interaction. Photoshop is a good example of an application. After you launch it, it keeps running, waiting for more interactions or for you to tell it to quit. The tasks that it performs are not a linear set of instructions. It jumps around based on the task that you want to do at that particular moment. But as I said, the lines get blurry. As scripts get more complex, they start to resemble programs, and the simplest programs are basically just scripts. So you could say it's a distinction without a difference, but we still call PHP a scripting language. Now, what does it mean when we say PHP is server-side? When we talk about server-side and its opposite, client-side, what we're talking about is where the code does its work. Does the code run on our web server, which is server-side, or on the user's computer, which is client-side? The client-side, when we're working with web pages, is the user's browser. As a contrast, JavaScript is an example of another popular scripting language, but JavaScript is a client-side scripting language. JavaScript code is sent to the user's browser, and then it does its work there. PHP code is never sent to the user. It runs entirely on the web server, and the results of that code is what's sent to the user's browser. That's an important difference. Because PHP runs on a web server, that means it generally can't run on its own, and we'll need to have a running web server in order to use PHP. PHP code does not need to be compiled. It's executed by the web server exactly as it's written. Other programming languages, such as C or Java, require the code to be compiled or translated into another form before it can be used. We'll be able to just write our PHP, put it where our web server can find it, and then we can load up the web page and see the results. PHP is designed for use with HTML. It can be embedded in our HTML, and we can use it to generate HTML. In the end, PHP is going to return HTML to the browser. PHP code is going to be our input, and web pages are going to be our output. Now, if you've been working with HTML, you're already familiar with having .htm or .html at the end of your file names. PHP is going to work exactly the same, but we're going to put PHP at the end. The PHP is going to tell the web server that this file contains PHP code that needs to be executed. PHP is going to provide more flexibility than HTML does on its own. HTML pages are static by their nature, so all visitors to a web page see that same page all the time. But PHP lets us create dynamic pages. The page content can change based on conditions, such as interactions with the user or data stored in a database. You can think of PHP as turbocharging your HTML. PHP syntax is going to be very similar to C, Java, and Perl. The small details are going to vary quite a bit, but the structure of logical expressions and loops, those kinds of things will be familiar to anyone with programming experience in one of these languages. Now that we know what PHP is, in the next movie, let's learn a little bit about the history of PHP. In this movie, we're going to make sure that you have a good text editor installed. This is what we're going to be using to write our PHP code. If you've been coding before, then you may already have a favorite text editor, and that's great. You can feel free to use any text editor that you want. The only requirement is that it needs to just generate only text at the end. That's what a text editor does. It's very different from a word processor, like Microsoft Word. That would be a terrible text editor. And the reason why is because that is focused on a different purpose. It's about formatting a document. So it keeps all sorts of extra information in the file, like where are your margins set, what are your tabs set at, what font is being used. All that information gets stored in there, and we don't want it in there. We want just our code, just the instructions that the Apache web server is going to read and process. In addition, text editors or code editors often have lots of nice features that make it easier to use and allow us to work faster and make less mistakes. So let's take a look at some of the features you want to watch for. The essential features, you want to look for code coloring and syntax highlighting. That is, you'd like the page to actually have colors to help tell you what is the HTML, what's the JavaScript, what's the PHP, where does the function start, and where are the different arguments to the function located. All those things can have different colors to them that help us to be able to read the code quickly and understand what's going on. They also usually need to have a way that we can navigate a whole project so that we can open up a project and move between the files quickly instead of having to always go back to the Finder, open up a file, work with it, and close it again. You want it to have good search and replace features, especially once you start working on a large project. It's really important to be able to search all your code to look for times when you've used a certain variable name, let's say. Maybe you want to change the variable name. Well, we want to replace it throughout the entire application. Make sure that we can find them all. It's also important to have good auto pairing of brackets, parentheses, and quotes, so that when we type an open bracket, it goes ahead and creates the close bracket at the same time, so that we don't forget to do that. They're always closed. When we're coding, that's super important that these are always paired up. And then preferred features, I would list off being able to auto indent so that when code needs to be indented, it goes ahead and indents it to the right spot. You don't have to hit tab to indent it. Code completion so that you can start typing and then often hit a key like tab and it will complete the thought for you. And customizing the coloring of the document and the coloring of the code. This is often referred to as themes. You can often have a couple of different themes and switch between them. So that's what I would say are the features you want to look for in any text editor. And of course, you'll want to look for things that are good for working with PHP specifically, so that it has good code coloring for PHP. Most of them will because PHP is so popular. Now, the one that I'm going to recommend that we use, if you don't already have a favorite, is TextMate. It's a great text editor, has lots of great features. It's created by Macromates. So macromates.com is the site to get it at. It has a free 30-day trial. It's about $50 to actually buy the program if you like it. There are other ones out there, though, that I want to just list off that you can explore and check into. Sublime Text 2 is extremely popular. A lot of people have been moving from TextMate to Sublime. And then Eclipse, NetBeans, Komodo, Coda, and BBEdit. Those are all other popular either editors or IDEs for Integrated Development Environment. That's what that stands for. So give all of these a look. Maybe TextMate won't be your favorite. Everybody seems to have their personal favorite that they love and they just won't part with. But if you don't have a favorite, then I recommend you give TextMate a try to start with. Let's see how we can get TextMate installed. So here I am on the macromates.com website for TextMate. You can see here is the free 30-day trial. You'll just click that button. It'll say where do you want to download it to. I'll just select the default for opening it. You could also save it to your desktop somewhere, and then it will download. There we go. Once that's done, I can close that up. And there it is. There's TextMate. I can throw this file away anymore. This is the application right here. So all you need to do is drag that to your applications folder. You can see that I already have my copy in here, but you can just drag your copy in and then you'll have it there. It's also not a bad idea to drag it down to the dock as well so that you have a copy down there running. Once you've got it installed, you'll just want to double click on it and it'll pop open with a new document. It may prompt you for some other information since yours is not licensed. My copy already is licensed. I've purchased it. And I just want to show you that you can change the way that this looks by going to TextMate Preferences, and then under the fonts and colors you can pick different themes. I've picked one here called Idle Fingers, and that's the one I'm going to be using. It has a black background, which I think is nice and easy for reading code. Let's open up our existing PHP file. We have that already. PHP info. I'll double click on that. You can see that it does code coloring. It puts it in red where everything else is not. That's one of the configurable options. You can also notice that it gives me line numbers here. That's also a nice useful feature. So you can read through their online documentation. It'll teach you a lot of the different tips and tricks of how to do things faster. But the main thing I wanted to make sure was that all of us had a good text editor to start with before we start creating our PHP code. In this movie, we're going to make sure that you have a good text editor installed. This is what we'll use to write our PHP code. Now, if you've coded before, then you may already have a favorite text editor. And if so, that's great. You can feel free to use any text editor that you want. The only requirement is that any application you use should generate only text at the end. That's what a text editor does. It's very different from a word processor, something like Microsoft Word. Word would make a terrible choice for a text editor, and that's because it's built to serve a different purpose, which is to format the text in a document. So Word documents are not just text, they include lots of formatting information as well, like what font you're using or where your margins are set, and we don't want all that formatting information. We just want the code, the PHP instructions that Apache will interpret to return web pages. In addition, text editors, or code editors as they're sometimes called, often include lots of other nice features that allow us to code faster and to make less mistakes. So let's take a look at some of the key features to watch for. The features that I'd list as being essential features are code coloring or syntax highlighting. That is, so that different parts of the PHP language will be colored in different ways. It helps you to quickly be able to read your code and identify different parts of it, to see what's a function, to see what's a variable, and you'll be able to read your code a lot faster. The ability to navigate a whole project at one time, so that you're not constantly opening files and closing files again, but that you can open them all up and quickly switch between them. Really good search and replace is a pretty essential feature, especially if you can search across the entire project, so that you can look for all occurrences where you've used a certain function. It can be really useful. And then auto pairing of brackets, parentheses, and quotes. The idea here is that it's really easy when you're coding to type an opening parentheses and then to forget to type the closing parentheses that you need on the other side. And your code will break if you don't have both. So a lot of these text editors will auto pair them. As soon as you type the opening parentheses, it automatically adds the closing parentheses right after it. And you keep typing right between those parentheses, but both the beginning and the end are both right there. A lot of times once you roll over a parentheses or a bracket or something, it'll highlight the matching one on the other side so that you can quickly identify the pairs. Now what I'd say are preferred features would be auto indent, so that when you go down to the next line in your code, it automatically puts your cursor indented to the place where it ought to be instead of having to hit tab a few times. Code completion can be a nice feature. The ability to start typing a function name and then hit some kind of a hotkey to get it to finish completing the rest of that name for you so you don't have to type it all out. And then customized document and code coloring, themes, the ability to not just be stuck working with black text on a white background, but to be able to change it up and to work with some colors that suit your eyes better and to even code your PHP how you like it. So if you want your function names to appear in blue, they can be blue. If you want them to be green, you can change them to be green. Now the text editor that we're going to be using is going to be a very popular one called Notepad++. And you can find that at notepad-++.org. Notice that it's .org at the end. If you go to .com, you won't get there.
And one of the great things about Notepad++ is that it includes lots of great text editor features, and it's completely free. That's one of the reasons it's become so popular, is because it's absolutely free to use, but it does everything that you're going to need. Now, there are a lot of other text editors and IDEs out there. IDE stands for Integrated Development Environment. And so I want to mention these to you because you might want to look into them and see if some of these suit your purposes even better than the default one that I'm giving you. And Sublime Text 2 is extremely popular. eText Editor is meant to be a similar version to TextMate, but on the Windows side, sort of a Windows companion to TextMate, but it's kind of disappeared recently, so it might be a little bit hard to find online. I don't recommend it as a default. We're going to go with Notepad instead. And then Eclipse, NetBeans, and Komodo are all popular IDEs that people use for a lot of languages, not just PHP, but for working with Java, C++, and things like that too. So let's download and install Notepad++. So you want to start by going to notepad-++.org, and once you're here, you'll see that there is a link here for download. And that will take us to the download page. Now this is the download link that will download the latest version for you. Over here, this is an ad, and you may have several of them over here. Ignore all of these download links there. The one that you want is the one that's right here, actually in the website. So we'll click download here, and it will say, all right, you want to save it? Where do you download it? So you'll say yes. I've already done that, so I'm not going to do that step again. But once you download it, then you'll have this installer. You'll just double click it. We'll give it permission to do the things it needs to do. Select our language, and then here's our wizard. Let's click next. We'll agree to the license agreement. Where do we want to install it? We'll let it install in the default location. Now check the components that you want to install. I'm going to go ahead and select the default set here. I'm not going to make any changes to that. And then it offers a couple of other options here. We don't need to worry about most of them. Create shortcut on the desktop though is going to be a good one because that'll give us a good way to get to the program in the end. And then we'll click install. It just takes a quick second while it installs the files. Now it's done. And then run Notepad is the option at the end. So I'll leave that checked. I'll click finish and it will actually launch the program for us. It gives us a change log of what's different about it. So you can surf around and explore and see the different options that are here, but it has the basic file options up at the top. We have the ability to do search. We have the ability to set different languages. So we have, for example, PHP that we can set as a language for our file, and then it will use code coloring on the file as PHP. And it should pick up that from the .php ending of the file name. And that's it. We now have Notepad++ installed and ready to use as our text editor.
Now that we have PHP installed, we're ready to start learning how to use it. We're going to start by learning how to embed PHP code in a page because there's some basic rules that we need to know about. We already did this in the setup chapter. We created our first file, which was my_phpinfo.php, and we populate with just this one little snippet of code. And you may not have completely understood what it was at the time. You may have just followed along. That's okay. We're now going to talk about it and talk about how this works. Notice that there's the beginning and ending to this line with a bit of code in the middle. I'll drop out the code in the middle so you can really see the difference. This is the beginning of opening a PHP tag and the end, closing PHP. What we're doing is essentially saying to the Apache server, hey, as you're processing this document, turn on PHP. Start reading the next little bit as being PHP code. And then when it gets to the end and it sees that question mark with the greater than, it says, okay, the tag is over. Now we're done with PHP. You can go back to doing your regular HTML rendering. This allows us to embed PHP into the HTML. Remember in the early introduction I talked about that that's one of the features of PHP is that we can just embed it in the HTML code. So we're essentially telling Apache to turn on and turn off PHP filtering as it's going through the document. And then in between, we can put whatever PHP code that we want. So if you look at someone else's PHP code, you're going to see these open and closing tags throughout the document as it's turned on and off. This isn't the only way that you can write these PHP tags. There's also something called short open tags. These, I would say, are considered bad form. This is using the same tags, but omitting the letters PHP from it. There's also a form that uses the question mark followed by an equal sign, which outputs the results directly. Normally, evaluating the PHP doesn't output results on its own. You have to tell it specifically, I want to output something here. Otherwise, you could just do some processing. You could add 1 + 1 and not output the results, just do a calculation in there. And that's what the second form is there. This has become more popular, especially a lot of experienced PHP developers have started to prefer having this shortcut, but I think it's still a bad idea, and we'll talk about why in just a second. The other way that you could do it is to use ASP style tags. I think this is considered very poor form. Instead of using the question mark, we use the %sign. ASP is Microsoft's version of PHP. It's what became ASP.NET. ASP was something that actually existed before ASP.NET. And this is the way that the tags looked. They had the % on either side. And again, we have that equals there. Both of these options are something that you can turn on and configure in your PHP INI file to allow them. Otherwise, you need to stick with the regular default PHP tags. So why am I saying that this is a bad idea to create these kinds of tags? Well, it's specifically because they're enabled in the PHP INI file. One of the wonderful things about PHP is that the code is portable. A version of PHP on Windows and Mac and Linux is all exactly the same. My code can just run on one, it can be moved to the other one and run there just as easily. But if I make a choice to use a different style of tag, and I require that the PHP INI file be configured a certain way, then my code stops being portable. Now, it will no longer run on this other system because it's not configured correctly. And I think that's a bad thing. If we just stick to the default standard tags, then our code will stay portable. And that's going to be especially true if you start writing code that's going to be a plugin for an existing application like WordPress or Drupal or something. You want to be able to distribute that and have everyone be able to use it. So you want to be in the habit of using good, widely available, widely supported PHP tags. Otherwise, I think you're shooting yourself in the foot before you've even started. There are a couple of other points that I want to make about your PHP code. If we open up our myphpinfo.php file, I want to show you that the white space doesn't matter. White space inside the PHP code doesn't matter. This is just as valid as what we had before. Same here if we put more returns in here, tabs, spaces, those are all considered white space. And PHP doesn't care about those. It completely ignores it. It just executes the code as you go through. And that's great because it allows us then to use white space to help us to create readable code. We can indent things, we can group things together so that it's really nice and easy for us to read and follow. We don't have to worry how the white space is going to be interpreted. Not all languages work that way, and it's one of the nice things about PHP. The other thing I want to point out to you is that notice that the command ends with a semicolon. That's part of the way that PHP helps to know when one command is over and another one is starting. Since white space doesn't matter, it needs to have some reliable way to know this command is finished and I'm ready to move on to the next command. So every line is going to need to end in a semicolon. So get used to it. It's a habit you're going to have to get in with working with PHP is to always put semicolons at the end of your lines. And there's one last thing that I want to show you before we move on. Let's just close this up. We'll save it and close it. And inside our index.html file that we created earlier, if you don't have it, you can just create one, a nice simple file inside here, index.html. Let's open that up and let's just drop a little bit of PHP in there. So open our PHP tags. You can see that it auto closed it for me as well at the same time. That's nice. PHP info with my parentheses and then the semicolon, right? So that's the same little bit of PHP code that I had. Let's save it. We'll close that up. And let's now go into our browser and let's load that file up. Localhost, Kevin Skogland, index.html. That's the file I'm loading up. I get hello from my user directory. I did not get the result of that PHP function. It has nothing to do with the fact that there was other text in there at all. In fact, if we view source, under web developer, I can choose page source. And you can see that it actually just output the code itself. It didn't actually do any PHP processing on it. So why is that? I gave it my starting PHP tag and my ending PHP tag. Why didn't it process it? Well, that's because the file ends in .html. It's important that we have both of those things. The file needs to end in .php. That tells Apache, hey, be on the lookout for PHP tags. There may be PHP tags in this document. And then when it sees a PHP tag, it turns on its PHP module, starts processing the PHP until we close the PHP section. So it's important that we have both of these, right? If we start naming our files ending in something besides PHP, it's not going to see it as being a PHP file and try and do any processing on it. Now that we have the fundamentals of how to use PHP tags to embed PHP code into our document, let's start trying to use that with dynamic text. If you remember back to the introduction where I talked about why you would want to use PHP, the real power of PHP comes from the ability to output dynamic text. That's what makes it different than just an HTML website. If, for example, we have an auction website and a new item has been posted for sale, it gets stored in the database, PHP goes and grabs it out of the database, and now the HTML page that the user sees is different than what it was a few minutes ago. This new item has been dynamically added to the page. So we're going to start looking at how we can output dynamic text. And we're going to start really simple by just outputting a few words. And then we'll build up to being able to pull things from the database and to actually output more elaborate stuff. To start with, we're going to learn the most important PHP that you need to know, which is the echo command or function. Echo is just simply going to return whatever we say back to the user. It's like an echo. We say something, that's what gets echoed back to the user so that they see it. You can think of it as like printing it to the user's browser. And we'll use it inside our PHP tags with whatever we want to echo back. So for example, open PHP tags, echo, space, and then inside quotes, hello world, semicolon at the end, and then close our PHP tags. That will send to the user's browser, embed on the page, hello world. No quotes, just the characters from the H to the D. Let's create a page where we can try this out. Now, instead of doing it on one of these other existing pages, I'm going to go into my text editor, TextMate, and I'm going to choose New from Template. It's a little different than what we did before. So just create a new file. I'm going to create an HTML file, and I'm going to pick the transitional version. That's just going to give me some basic HTML at the top. I'm going to remove some of these bits, make it a little simpler, and do some indentation on it. And then I'm going to save this file in my sites directory. I'm just going to save it as basic.html, and that'll be an HTML file that I can pull up anytime I want to work with and to make a copy from. Now notice it's .html, so we can't put PHP in it, but I'm now going to do save as on that document, and I'll make a new one from it, and I'll call it hello world.php. Okay, so that's in the same folder. I now have both of those. This one I'll be coming back to often whenever I want to get some HTML again. And then this is the one we're working with now, .php, ready for PHP to be embedded. Let's put hello world at the top. And let's embed our PHP code here. Let's open up our tags, PHP, echo, open the quotes, hello space world, exclamation point, then the semicolon, and then close our PHP tags. So there we go, nice and simple. We'll save it. It's always important that you must save it because Apache is going to read whatever's saved on the hard drive. Whatever's open in the text editor and not saved, that's only on our screen. Let's go into Firefox and let's open up localhost and Kevin Skogland, hello world.php. And there it is. Now let's do view source on that. Under tools for web developer, page source, and you can see that it output all of the HTML, and then right here it just dropped in that text. No quotes around it, just drop that text right into the body. So you see how we can embed PHP. That's what we would have expected to happen. It output it right there. Now, if we take away the echo, if we just have the string by itself, and we reload the page, then it doesn't output it. We still get the HTML. We could still view our source and see it's there, but it didn't output anything. The echo is a very important part of outputting that to us. Let's try another one. We're going to learn how to concatenate two parts together. So we have hello world, but this time let's put quotes here so that it's two different quoted strings. Hello inside quotes and world inside quotes. And I've got an extra space in here right before world. This period is going to concatenate them together. That is, smash them together, dynamically generating one new thing that gets echoed back. So this is a very common technique, is to echo things and also to concatenate things together. If we go here and we take a look, you see we get hello world 2 times. Now, it's not on a new line, right? There's nothing here to tell it to go to a new line. It just echoes one. Then the white space, this is just HTML white space. It just says put one space in there, and then followed by our next command. If we want to actually have a line return, well then we need to format it with our HTML. We need to have like a BR tag. So it's a very important point. Just because we see a new line here between our PHP tags doesn't mean that it generates a new line. We still have to write the HTML to make that happen. All right, next I just want to show you that we can also generate doing 2 plus 3, and we'll just return that back. Let's first take a look. Let's put another BR tag. Let's take a look at it this way, and notice that it didn't output anything. Well, it's because I didn't echo it. I always need to echo it. It did the calculation. It did actually add 2 plus 3, but then it just threw away that value. It didn't do anything with it because I didn't tell it to print it to the screen using echo. Now, the one last point that I want to make here is that the semicolon is a separator that I've told you that you always need. It's a good habit to always have in your PHP. In this case, when it's a one line, you don't actually need it. Apache is able to tell when it's parsing the PHP that this is the end of the PHP because we have an ending tag here. and it will keep it separate from this one because it's in a separate tag. So we don't, strictly speaking, have to have the semicolons. However, I think it's a really good practice to just always, always, always use the semicolons. And that way you won't be tripped up by the sometimes that you use it and sometimes you don't. Just get in the habit of always using a semicolon and you'll never run into problems. Now that we're able to output dynamic text, I want us to pause for a second and take a look at how the web server processes these PHP pages, because I think that process is going to be instructive. We'll do that in the next movie. In this movie, we're going to take a look at the request response cycle in PHP. This cycle describes the way that a browser and a web server communicate to process user requests. Especially if you haven't done web development before, it can be useful to see this cycle laid out for you. To start with, we have our browser, and then we have the web server. Our browser makes a request to the web server. That's when you type in the domain of the site. So let's say that you type lynda.com, it sends a request to the lynda.com web server. In our case, that's going to be localhost though. And on that web server, software needs to be there to intercept that request. And we have an HTTP daemon called Apache that's there. And Apache sees the request and says, oh, okay, I'm going to see if I have a file that will help me to respond to that request. It then goes to the file system and looks for a file. Let's call that file hello.php. Apache grabs that file and then says, okay, I see that it has .php at the end. There may be PHP in here that needs processing. No problem. I will do that. So it goes to process the PHP. In the course of doing that, it may need to go back and forth to the database a couple of times. It may need to request some information from the database, store information in the database. All sorts of things can happen as it goes back and forth between there. But once it's done processing the PHP, there's one final step where it assembles the HTML that's going to be returned and then ships that back to the browser. And that's the response that the user sees. So it's very important that you see this cyclical process from the browser to the web server, where it goes to the file system, processes the file, goes to the database as many times as it needs during that process, and then finally generates HTML that's sent back to the browser. There's no chance to process PHP after the HTML has been completely generated. There's no chance to do it once it's gotten to the user's browser or anything like that. It happens only in this one spot where we process the PHP after Apache goes and finds the file. This is often also referred to as the request response cycle, because we're making a request to the server and it's responding with something back to us. So it's a request response cycle. Now, while this may seem simple, I think it's very important for you to keep this in your head as a mental picture as we continue to develop with PHP, because a lot of things that we're going to learn, like header redirection, output buffering, setting cookies, all those kinds of things are really going to be affected by this cycle. So it's important to have a good, firm understanding of this right from the start. In this movie, we're going to learn how to insert code comments into our PHP. We don't want to become simply capable developers. We want to become good developers. And in order to do that, we need to learn about code comments, something that's very important in any programming language. You want to add comments to your code so that you or someone else coming to look at the code later can quickly understand what your code is trying to accomplish and understand the approach that you took. Comments take additional time to write, but they pay off and save you time later. In PHP, there are a couple of ways we can write comments. We can make single-line comments by simply opening PHP tags and then putting in / followed by our comment. Single-line comments are like this. Or we could use a £, or like this, but that is less common. Mostly you're going to see people using the / in front of it, and that's what I'll be using throughout this title. Now let's just save that document real quick, and let's go over here and let's reload this Hello World page in our browser. So there's the page. Let's do view source on it, web developer, and page source. And you can see that the comments do not show up, right? Just the things that I echoed out, just the output. So these comments are not output into our HTML, and they are not processed as PHP. They're just simply ignored. They're there for our benefit only. Now I want you to note two things about them. First of all, this only works inside PHP tags, right? If we did it up here, then that's just HTML that we're writing. That's just text that will be output. So we can't put them there. And also this technique doesn't work for double lines. So for example, if we have double line comments that keep going, oh, wait a minute. Notice the TextMate actually helpfully colored it a different color for me. The brown text color indicates that it's a comment. The blue is indicating that it's going to be trying to process this as some kind of PHP, and I'm going to get an error. Now we could just put more / in front of it. That's certainly valid to do your comments that way. But I also want to show you that you can do double line comments by putting a / with an asterisk after it. So double line comments are written like this so that you can keep typing. I'll just indent a little bit and typing. And you can do that all the way until you type another asterisk and a /. So everything in between these is all going to be commented out. It's a little bit like turning on and off the PHP tags for PHP processing. We're saying this whole thing is a comment until you get to the ending comment marker. Just assume that we're still in comment mode. And this is great because it allows us to type entire paragraphs describing what our code does. Now, of course, one thing I want to caution you about is you don't want to try and put a multi-line comment inside another comment, because as soon as you get to the first ending /, right, even if we have another starting / test, right, it's going to close it and turn off commenting mode. They're not nested. So 2 turn-ons does not equal 2 turn-offs, right? As soon as we get to an off, that's it. It's out of comment mode. And let's save that, and then let's just come back over here and reload the page one more time and take a look. View source, and you can see that it doesn't show up there either. Comments are super important to writing good code. It can be hard to be disciplined about it. You get caught up in writing the code, and often you forget to leave yourself comments. But once you start programming a lot, you'll realize that comments are going to save you a lot of time. Not now, but 10 weeks from now, when you come back to the code and you can't remember what you were trying to do or why you chose a certain approach. It's one of those things where investing a little bit of time in the beginning is going to save you lots of time later on. And comments are especially friendly if there's ever someone else who's going to be working with your code, because they don't know what you were thinking. They don't know the reasoning that you went to arrive at a solution to a certain problem. But your comments can make it clear to them. So I'd like you to make a promise to yourself right now that you're going to try and put as many comments in your code as you can, especially while you're still learning PHP. Our exploration of the PHP programming language is going to begin with an exploration of the different structures or types that we can use while writing PHP. And the first of those that we're going to look at are variables. Now, if you've done programming before, then you're familiar with what a variable is. But if you haven't, let me start by explaining that a variable is a symbolic representation of a value. You can think of it as a symbol that refers to something. And that's going to make a lot more sense once we actually start using them. But as its name suggests, it can change over time or vary. It has a variable value because it can point to different values. Now in PHP, there are some rules about the kinds of names that we can give to variables. They need to start with a $. That needs to be followed by either a letter or an underscore. They can contain letters, numbers, underscores, or dashes. They cannot contain any spaces, and they are case sensitive. It makes a difference whether we use an uppercase letter or a lowercase letter. So let me give you some examples of some variable names, and then we can talk about them. So I could have item, which is just $item, and that could be a symbol that then points to an item. So maybe it's just number 5, right? Item points to number 5. I could also have item with an uppercase I. Either one is perfectly fine, but they are different. If I have 2 of them, if I'm using both of them, and I have item lowercase pointing to the number 3 and item uppercase pointing to the number 5, then depending on whether I use uppercase or lowercase will determine which one I get back. So you want to make sure that you're consistent with your capitalization. We could also have my variable with a capital V. That is often referred to as camel case because those uppercase letters in the middle are like the humps in a camel. So some developers like that format. Then there's the underscore between words. So this underscore variable. There's also a dash, this dash variable. That's perfectly valid. You can put numbers in it. So product 3. That's perfectly valid to have a third product named that way. You can put underscores in front of it. Remember, the first character has to either be a letter or an underscore. So you could have underscore book. You could even have multiple underscores. $__ book page. Now, all of these are valid. Any of these will absolutely work, but I want to steer you towards some and away from others. The first one is I think we should not use the hyphenated version of this. And the main reason why is that that hyphen looks like a minus sign. And it looks like we're subtracting this minus variable. When we start working with variables and we start doing addition and subtraction, that could be confusing for us. So let's avoid confusion and stay away from that. The second one is this multiple underscores. Stay away from that as well because it makes it hard to tell whether you've got 1 or 2 underscores. I once worked on a project where another programmer had written their variable names using underscores, and sometimes they had 1 underscore, sometimes they had 2, sometimes they had 3, and it had significance to them. There was a reason why they were using 1, 2, or 3, but it was really kind of lost on me as to what the meaning was behind these, and it was hard to read to tell whether it was 1 or 2 or 3. The last one is not quite as evil, but I want to steer you away from it, and that is this single underscore at the beginning. The reason it's not evil is that PHP is going to use it itself, and we're going to see that. We're going to see that PHP has some special variables that are named with this underscore at the beginning. And some developers use this underscore for special cases. They want to denote the fact that a variable has certain access privileges, that certain people can or can't access things by putting that underscore in front of it. Because it has this special meaning, both to PHP and to other developers, let's stay away from it for general use. Let's go with the other ones. Now, the one that I'm going to use most often, the one that I prefer, is the fourth one in this list, this underscore variable. And that's what you're going to see me using throughout the title. But you can use whichever one you feel most comfortable with. Now, you can't just use any single name that you want. PHP actually has some words that are reserved, words that you're not allowed to use for different things. And it's a good idea to take a review of this list and then stay away from those words as much as possible. Sometimes it's not a problem to use it for a variable name, but it might be a problem to use it in other contexts. It's basically just names with special meaning to PHP that we don't want to use. Now let's try using some variables. Before we do that though, let's open up our sites folder. Let's get all the way inside that sites folder and let's create a new directory inside here. So File, New Folder, and I'm going to call this Sandbox. I find that it's very helpful to have a sandbox where we can put all of our miscellaneous files like the ones that we've been working with here. So I'm going to grab basic HTML, hello world, my PHP info. I'm going to put all of those inside my sandbox. This index.html file I don't actually need anymore, and I can just throw that away. So all of my files now are inside my sandbox, and this is going to be a little place where I can try experiments out, certainly while I'm learning PHP, but even after I'm actually developing. I can just jump back to my sandbox, try some things out, see if things work the way I expect, and then switch back to my application to apply what I learned. I do this all the time, so it's really helpful to have this kind of PHP sandbox. Let's now open up our basic.html file, and let's just do a save as on that, and let's save that in our sandbox as variables.php. Let's just make sure that it ended up in our sandbox. You see there it is, and notice that it ends in .php. So now we're ready to put in some PHP code. Just give myself a little room here, and we'll change the name to variables. Okay, so we're ready to write some variables inside our PHP code. And to start out with, let's just do a simple assignment. Variable 1, that's the name of our variable, var1, and then we're just going to say it's equal to the number 10. That's it. We've now made that symbolic pointing from the variable to the number 10. Variable 1 now points to 10, and if we talk about variable 1, we're talking about 10. So if we then on the next line say echo var1, it's going to echo back 10, right? Let's save it and just try it. Go back to Firefox, and instead of hello world now, we want variables. Yep, I forgot I have to put sandbox in front of that because I've now moved everything to the sandbox. There we are. So there's the number 10. See how that works? It didn't output the actual string var1. var1 is a variable that points to 10. And of course, this value can vary. I'm just going to take these two lines and let's paste it. And now let's say it's equal to 100, right? Let's save it. And before I output it, I'm just going to also echo a BR tag in between them. I can echo HTML just like I can anything else, and it will output that BR tag in between the two of those. Let's try reloading the page. Now we got 10 and 100. So var1 the first time points to one thing, the second time it points to something else because I changed its value. It varied. Notice also that it's case sensitive. If I had said that this was equal to, I was going to echo back var1 with a capital V, and I save it, it comes up and it says, oops, we have a problem here. I don't see that var1 with a capital V has been initialized, and I get a warning message. This is what a notice looks like in PHP. So var1 here is different from var1 with a capital V there. Now variables don't only point to numbers, they can point to other things as well. So for example, we could have var2, it's going to be equal to hello world. And then echo var2. Save that, come back here, reload the page, and And you can see that now it outputs hello world. So variables can point to anything really. It's just a symbolic representation of something larger. It gives you a sort of handle, an easy way to work with this larger thing and just refer to it by this symbolic name. We'll continue working with variables and text like hello world in the next movie when we talk about the data type called strings. In this movie, we're going to be learning about the data type called strings. Strings are a very common feature of most programming languages, and we've already been using strings without knowing it. A string is a set of characters. Those characters can be letters, numbers, symbols, and they're going to be defined inside quotation marks, either single quotes or double quotes. In non-programming terms, you can think of a string as being text. In the last movie, when we were working with hello world is an example of a string. So is the BR tag. That's a string as well. It's defined inside those quotes. It is a string of text that we can then work with. Let's take our variables.php page and do a save as on it so that we can create a new one for strings. Strings.php, saved in our sandbox. We'll call it strings. And I'm going to take all of the PHP that's in here and let's just take it all out and we can start fresh with our strings. Let's start out with just a simple echo of a string, right? Hello world. We saw that before. Nice and simple. We can also put HTML inside of it, right? That's perfectly valid. That's a string. We can output it and it will output the text hello world followed by the HTML tag BR. We can also do the same thing but with single quotes. I'll just copy and paste it and I'll replace the double quotes with single quotes. In general, I'd like you to start getting used to using double quotes though instead of single quotes. And in just a minute we're going to see why. Now we also saw that we can assign strings to variables. So for example, if we have greeting equals hello, and let's have target equals, and we'll have world, and then we can actually put those together, phrase equals the greeting, and then we learned how to concatenate with that dot, and I'll put another string that has a single blank space in it. That's still a string even though it only has a blank space, and then target. Then last of all, let's echo that phrase. All right, now that we've got a few of these, let's bring them up in the browser and try it out. So let's go to Firefox, and instead of variables, we're going to be going to strings. So there they are. They all came back just fine. Hello world, hello world, hello world. Now we can also do variable replacement inside a string. Let me show you how to do that. Let's drop down here. I'll do a BR tag. Let's open up a new set of PHP tags. And let's do the variable replacement down here. So let's say that I have echo, and this time I still have phrase defined, right? The fact that I defined it in a different block of PHP doesn't matter. This variable is still set. And inside double quotes, I'm going to tell it to echo phrase space again. Now let's go ahead and put BR tags at the end. So I've now put the variable inside of the double quotes. Because it has the $sign in front of it, PHP is going to see it as being a variable. And it's going to pull up the value that was here. Let's try that. See? Hello world again. So it dropped in that phrase followed by again. Now this only works with double quotes. That's why I think it's a good habit for you to get in using double quotes instead of single quotes. Let's just change this real quick to single quotes and you'll see what happens. It just comes back with the literal phrase again. It doesn't do the substitution. That only happens with the double quotes. Now there's a problem with this, right? Let's imagine that we have our phrase here, hello again, but what if we didn't have a space? What if we were trying to use a variable and then right after it wanted another bit of text? Well, if we run this, PHP is going to see that as being one variable. It's going to look for phrase again as a variable, but that doesn't exist. Well, the best way to do these inline replacements, I'm going to select it all, and then I'll put curly braces on either side of it. Now I'm going to clearly differentiate what is the variable from the non-variable. When we're inside the double quotes, they have this special meaning, and they allow us to put variables inside of them to do this in-place substitution. You can put slashes in front of it if you wanted to have the literal curly quotes. Same thing if you wanted to have literal double quotes inside of your double quotes. You could use a backslash double quote in front of it. The backslash escapes the value and lets us use it. So let's see what this looks like. Let's just save it, switch back over, reload it, and see it works here. Right now it was able to still find it and still do in-place substitution. So I think if you're going to do in-place substitution, this one is your best bet. This one is the one that allows you to make it really clear what you're doing. This is a variable that's being dropped into the string. So try and use those curly braces. Of course, it is still just as valid to do it by concatenating the two together instead. And you'll find yourself using both. Now that we understand the basics of strings, in the next movie, let's take a look at some string functions that are going to be really useful. We've seen the basics of working with strings. Now I want us to take a look at some functions that we can use with strings. We haven't looked at a lot of functions yet. So far we've really just looked at the PHP info function and echo. Those are really the two main functions we've seen. So we're going to start diving into the world of functions. And before we do, I just want to remind you that the php.net website has some excellent documentation for functions. And it will tell you all of the different functions that are predefined in PHP. It'll tell you how to use them, has good user submitted tips for you. All of that's there. And you can browse through those if you're looking for something and you're not quite sure what it is. Or if you know the name of the function, you can just type it into the search bar at the top and it will return the documentation for it directly. All right, let's take a look at a few. So let's start by opening up our strings.php that we were just working on before. And we'll just do a save as on that real quick and make this string underscore functions.php. That's what we're going to call it, string functions. And let's take everything out between all these PHP tags here. There we go. Now I have a nice space to drop in my code. I'm going to start by just pasting in some text so that you don't have to watch me create it. You can pause the movie if you want to copy some of this down. I've got a string that I'm assigning to the variable first. String is the quick brown fox. And I've got another string jumped over the lazy dog with a space at the beginning that I'm assigning to second. So we've seen how we assign variables to strings like we're doing there. And we've also seen concatenation. We've seen how we could just concatenate these before. I want to show you another way to do concatenation real quick. We can do concatenation and assignment at the same time. So let's say we have third. It's going to be another variable. And third is going to be equal to first. And then on a new line, it's going to be third is equal to concatenated equal to second. All right, do you see what it's doing there? So it says, all right, first of all, third points to the same thing as first does. Can get that same string and bring it into third. Now, in the next line, I'm going to tell third that it should add on the second string to the end. It should concatenate it to what's already there. It's like appending it to the end. The values of first and second haven't changed. Those values are exactly the same still, but third now has the complete phrase in it. This is going to be a very handy way to write your code if you're trying to build up a string over time. We'll definitely use it when we start working with MySQL later on. And of course, I could then say echo $third. All right, so now that we have our third string, let's take a look at some functions. I'm just going to drop down here a little bit. Let's put in a br tag. And then instead of opening up PHP tags again, I'm going to paste in some more text here. This includes some HTML as well as PHP tags calling some functions. So these are the string functions that we're going to be learning. The first function that I want us to look at is string to lower. So strtoLower, that's the name of the function. And functions often take something as an argument. They take something as input into the function, and then they return output to you. So the input in this case is going to be inside the parentheses, and it's going to be our variable third, which is equal to the quick brown fox jumped over the lazy dog. So that whole phrase is being sent into string to lower, and you can guess what string to lower does. It lowercases it. So it then returns a lowercase value, and then echo, another function, echoes it back. So we're calling one function on the results of another function. The argument to echo is the results of string to lower. Now we have the same thing here with string to upper, raising it to uppercase. UC first is going to make the first letter uppercase, and UC words will make the words all uppercase. So let's just try that out so we can see what it does. So let's save it. Let's go back to Firefox, and instead of strings, we're now going to be loading up string underscore functions. So there it is. So you see here's the original phrase that we echoed the first time. Here's the lowercase version, the uppercase first only. Everything else stayed lowercase, and uppercase words where each one gets uppercased. So make sure that you understand that idea before we go on. Let's just do a few more here. I'll just put a br tag. And we're going to do length, string len, strlen is going to tell us the length of a string. Trim, I'm going to use a different phrase here just to illustrate it. What trim does is it removes the leading or trailing white space, right? That's spaces. No matter how many there are, it gets removed. So I've got A being concatenated with a trimmed version of BCD followed by E. All right, so there should normally, if there was no trim here, it would be A space, B space, C space, D space, E. But the trim is going to take out those spaces. We'll see that in a second. Find, which uses str. That's the function name. The way you can remember that is that you're finding a string within a string. That's why it's called str. So inside the string that third points to, we're going to look for brown. We'll see what that returns. And then replace by string is going to replace quick with super fast inside third. So it takes 3 arguments, right? So we now have something that takes 2 arguments, and another one that takes 3 arguments. The order of those arguments is important, and it's something that you have to look up or know already from the way the function works. And you can look those up on the php.net website if you forget them. The way that string replace works is it wants the thing you're looking for, the thing you're replacing it with, and then the item that we're searching inside of. They call it the haystack often. We're searching for a needle in a haystack. Well, the haystack is third, and the needle we're looking for is quick. We're looking for quick inside third, and we're going to replace it with super fast. So let's try those real quick and see what those look like. Go back and just hit reload. So the length of it is 45 characters long. That's how many letters and spaces there are in there. Notice here that the spaces got trimmed out of B, C, D, so that there is no space now between A, B, and D, E. Find did find the word brown. Notice what it returned to us. It returned everything after that in the string. So it found it, and the result, what it returned back, was not just the word itself, it was everything that follows. That's the behavior of find. Again, the documentation will tell us that that's the way it behaves, and we might want to slightly modify that or account for that in our code to handle it. If we were looking for something like we want the word that follows brown, well, we have to apply a few more functions to it so that we could get the word fox from that. Replace by string, you can see that it put the super fast brown fox. So it did exactly what we would have expected. Okay, let's look at one last set, br. And we're going to look at repeating, str_repeat will repeat a string. It's going to repeat third 2 times. Echo substring, substr, that's going to make a substring from third, starting at the 5th position to the 10th position of the string. And string position is going to tell us the position of brown. It tells us where brown is located. Or we can find a character. Where is the character Z located? And it'll return a number to us, telling us where that's located. These positions can be really helpful if we're trying to parse out, we're trying to find where something is and then make a substring from it. Then you can see how we can use a combination of tell me what the position is or find it for me, and then make a substring starting at this position going until whatever position is, the ending position. Let's try those out real quick. Let's go back. And you see repeat, the quick brown fox jumped over the lazy dog, the quick brown fox jumped over the lazy dog. Make substring, you can see where it grabbed. It grabbed from the 5th character going forward. Notice that the 5th character is 1, 2, 3, 4, 5, right? So that's where it started, is from the UIC. And then find position of brown is in the 10th position. And then find character, we were looking for Z. It works the same way that find did, right? When we were up here, it found brown and returned everything after it. Returning Z returns everything from Z going forward from there. So these are your first set of functions. This is the way that PHP is going to work. We're going to be able to manipulate all sorts of things by using different functions. And these are the string functions. These are not the only ones. There are a lot more. And I don't expect that you will have memorized all of these. You're going to be looking them up for a while till they become second nature to you. You're going to have to make yourself some notes. Keep yourself a little chart. Maybe jot down the ones that you use most often so that they're there as a handy reference. Or just keep the php.net website open so that you can quickly go and search and look up how you use each of these. I've been using PHP a long time, and I'm still constantly looking up the usage of these and the order of the arguments and that kind of thing. Now that we've explored strings and string functions, we're ready to move on and look at integers. Over the course of the next 2 movies, we're going to be talking about numbers. And we're going to start out by first talking about integers. Integers are whole numbers, so that's numbers like 1, 2, 3, 4, 5, as well as -1, -2, -3, and so on. I think what a number is pretty intuitive. We all kind of have an idea of that by now, but we do still need to see how we work with them in PHP. Let's create a new document we can work with. I'm going to open up basic.html, and I'm going to just do save as. I'm going to change this one to be integers.php. Make sure we've got PHP at the end. Integers. Now we've seen how we can just have our basic PHP tags and assign a variable. var1 equals 3 and var2 equals 4. And we saw how we could add those together and we could echo back the result. Let me go ahead and just show you a bit more math. We're going to be echoing the result back from adding 1 plus 2 plus the value of var1, that's 3, and then multiplying that by var2. This asterisk is what we use for multiplying when we're programming. And then the result of all of that in parentheses is going to be divided by, that's what the forward slash here means, it's divided by 2 minus 5. Now the parentheses, the order of operations between the multiplication and division, all that is going to still apply. It's just basic math. It follows the basic math rules. So let's try that out. Let's open that up in a browser. Instead of string functions, we're going to be looking for integers. And there it is, basic math. The answer is 7. So it added all of those together and did a calculation for us. Let me show you a few other math things that we can do, and that's to use some functions. So here's if you want to find absolute value, you use the ABS function. So 0 minus 300. That will, of course, return the absolute value, which would be 300 instead of negative 300. Exponential, raising something to the power of something. The function we're going to use is pow. So you see the arguments are 2 and 8. So that's 2 to the 8th power. And then we have the square root, SQRT, the square root of 100. And then fmod is for modulo. Now, if you've never worked with modulo before, what it's going to do is it's going to take 20 and divide it by 7 and return just the remainder to me. What's left over from that? If things don't divide evenly, it'll tell us. That can be very handy for finding out whether one number divides evenly into another number. And then rand, of course, will return a random number to us. And rand with a minimum and maximum value will return a random number within that range. Let's try all of those out. Save it. Switch back. And here you go. Now you can see the random number it gave me was a really large number, whereas the random min-max it gave me was between 1 and 10. If we reload that page, you'll see that it gives me different values for each of those this time around. And you can see also what I was talking about with modulo. We were dividing 20 by 7. 20 by 7 will divide into it twice with 6 left over. So the modulo is the remainder that's left after that. So we could know that it does not divide evenly. In addition to these functions, I want to also show you how to increment and decrement the numbers a little bit. Let's do a new row here. And first I want to show you how to do plus equals. So we'll do some PHP. And we're going to say var2 plus equals 4. Now what that's going to do is it's going to update variable 2 in place by adding 4 to it. It's the same way we were doing that concatenation and assignment at the same time when we were working with strings. And it's the exact same thing as if we had actually typed out var2 equals var2 plus 4. It just saves us some typing to write it this way. Let's echo that value back just so we can see what it is. var2, we'll put a br tag at the end. Now, not only is there the plus version of this, but there's a minus version, a multiplication version, and a division version. So we can do all of those as well. And just so they aren't all exactly the same, I'm going to change this 4 to a 3. So that'll multiply it by 3 and then divide it by 4. Let's try those out real quick. Save the document, switch back. We'll reload the page. And you can see that it took the last value, so it starts out with the value of 4. It adds 4 to it to get 8, subtracts 4 to get 4, multiplies by 3 to get 12, and then divides by 4 to get 3. Now, incrementing and decrementing by 1 is super common, especially when we start working with loops. Let me just show you how that works. So we're going to call this increment. And if we want to increment plus equals 1, we could just do it like that. There's nothing wrong with that, and it might actually be very clear what we're doing. But it's so common that we can just do it as var2 plus plus. That just means add 1 to it, increment it. And this actually comes from the world of C. C uses this when we're incrementing loops. It's just a nice handy shortcut. We can do the same thing for decrementing with minus minus. So if you're going through a loop and you want to keep a variable incremented every time you go through the loop to count your iterations through the loop, you can do that by using this plus plus or minus minus. And we can try it out real quick. As you would expect, it comes up and tells us that it went from 3 to 4 and 4 back down to 3. The last thing that I want to show you about integers before we move on to floating point numbers is I just want to make sure that it's clear to you that there is a difference between the number 1 and the string 1, right? Those are not the same thing. This is just a character. It might as well be X or Y or Z. It's just a character on the screen. It's not a number that's ready to be added. Now, in truth, PHP will do its best job to add it together. If we did something like this, PHP will say, all right, I realize this is not a number, so it's not suitable for adding, but I wonder if I can convert it. I wonder if I can change it into an integer so that I can complete the operation. And it will do that. Let's just see that real quick. And you see it came up with 2. But if I said this is 1 plus 2 houses, you see it comes up with 3. The word houses just disappears because it converts it, and the best way it can convert it to an integer is to pick the number that it sees out of it and throw the rest of it away. And that's the only way that it knows how to. In general, you should not rely on PHP to convert strings into integers for you. You should be working with one or the other, and you should intentionally switch from one to the other if you really need to. And we'll talk about how to do that later on. But it's considered sloppy programming to combine types like this without explicitly converting them to the right type. Now that we've taken a look at integers, I want to take a look at another type of number, which are floating point numbers, also simply called floats for short. You may know them more commonly as decimal numbers. That is, numbers that have a decimal in them, followed by a number of significant digits. 2.75 is an example of a floating point number. Now, it may seem arbitrary to you if you haven't done a lot of programming before that we divide numbers into these two types, integers and floating point. And the reason why is because computers store integers and floating points in different ways in memory, mostly because of those significant digits that we have to keep track of with floating points. Because of that, almost every single programming language has 2 different types to work with integers and floating point numbers. So let's look at how PHP works with floats. So I'm going to start by opening up basic.html, and then I'll just do a save as on that. And let's just change this to be floats.php and save it in our sandbox. We'll call this floating point numbers. And let's create our first floating point number here. So inside the PHP tags, I'm going to have echo $float equals 3.14. That is an example of a floating point number. And floating points interact just fine with our integers. So for example, if we have our $float plus 7, we'll echo that back. Let's put some BR tags here just so we get them each on new lines. And we can also divide 2 integers together in order to get floating point number. So 4 divided by 3 doesn't divide evenly. So as a result, we end up with a floating point number. Let's try those out. So I'll switch back over to browser and we'll go to floats. So there we go. You see that it echoes the first value, 3.14. It adds 7, an integer to it, and gives you a result, which is also a floating point number. Doesn't matter that we have 2 different types. It handles them. They're both numeric, and so it knows that they can be added together. And the result might be an integer, or the result might be a float. One important point that I want to make for you is just that we can't divide by 0. Just be aware of that. It does not give us any kind of a floating point number or anything. It's an illegal operation, and we'll get a warning if we try and divide 4 by 0. Let's just try that real quick so you can see. It comes up and it gives us a warning, says, oops, there's a warning, can't divide by 0. Once we learn how to do conditional statements, we'll be able to check and see and have one behavior if something is 0 and another behavior if it turns out not to be 0. There are some functions that we can look at with floats that are specific to floats, and that is basically regarding rounding. What do we do about rounding them to a certain number? Round, the function round, takes a number that says how many significant digits do you want there to be. So float comma 1 will take my float number at the top, 3.14, and round it to 1 decimal place. Ceiling and floor are also a kind of rounding, except that ceiling always rounds up and floor always rounds down. It doesn't follow the normal rules of rounding. Notice that ceiling is actually CEIL, that's the name of the function name, CEIL, and floor is the other one. Let's try both of those out. Let's save that document, switch back to Firefox and reload. And you can see that it rounded 3.14 to be just 3.1. It rounded it up to 4 when I used ceiling, and it rounded it down to 3 when I used floor. Those are handy tools to have, especially anytime something doesn't divide evenly. You can decide whether you want to round up or round down with the result. Now with both integers and floating point numbers, we're able to ask PHP whether or not something is an integer or whether it is a float. We can do that like this. So for example, I can have PHP, we'll set integer equal to just 3, and then I'll just paste in a bit of code down here, and it says now, is integer an integer? Is float an integer? And then I'm going to use this method over here, which is is_int, to tell me, true or false, is it an integer or not? So whether or not it's an integer, it'll report back to me. We can do the same thing for float. Is it a float? And the method there is, of course, is_float. So it'll return true, false for whether each one of these is an integer or a float. And there's one more, which is we can use numeric on both of them, and we'll see what that gives us. Numeric is numeric. All right, now notice that this is underscore int. Is underscore integer also works. That's an alias for it, but is int is much more common. That's the one you'll see most people using. Let's try those out. We'll go over to Firefox and we'll reload the page. Is 3 an integer? Yes, it responded with true. And true, when it gets output as a string, gets converted into a 1. That's something we'll talk about when we talk about true and false later on. Is 3.14 an integer? No, it's false, so it gets converted to nothing, so that we see no result there. Is 3 a float? No, it's not. Is 3.1 a float? Yes, it is. Both of them, though, are considered numeric. They both belong to this larger type of being numeric. So this gives us the tools to be able to know whether something is a float, whether it's an integer, or even just whether it's a number, regardless of which one of the two types it is. These kinds of tests can come in handy. Now that we understand how both integers and floating point numbers work in PHP, let's take a look at another type, which is arrays. Arrays are a common feature in many programming languages. Arrays are going to be extremely useful for helping us to keep information organized. So what is an array? An array is an ordered, integer-indexed collection of objects. That's a fancy way of saying that we can take objects like strings and integers and put them into a group, and then keep their position in that group in the same order, so that we can refer to those objects by their positions. We can tell the array, give me back the first object, give me the fifth object, and so on, because the objects are going to be indexed according to what position they hold in the array. One good way to think about arrays is that they're like those expanding file folders that you can buy to put your bills in. You might put your electric bills in the first pocket, your phone bills in the second pocket, your mortgage payments in the third pocket, and so on. You have a preset order, and you can put things in pockets and take them out again. Put this paper into the third pocket. Show me the paper that's in the fifth pocket. That's the way that arrays work. Now there's no limits to how many pockets your array can have, at least none that you're going to need to worry about. And a pocket can contain anything that a variable can contain. A string, a number, even another array. In fact, a pocket can be just plain empty. And an array can be assigned to a variable, which makes it easy for us to reference a large collection of information by using a single simple variable name. Let's try an example. Let's create a new page for ourselves. We'll open up basic.html. We'll do save as, and let's call this arrays.php. I'll change the title to be arrays, and let's create our first PHP tags here. Now the first array that I'm going to create, I'm going to assign to the variable numbers. Now the way that you define an array is array, open parentheses, close parentheses, and that's it. We now have defined an empty array and assigned it to numbers. There's no objects inside this array, it's just empty. We can put a series of objects in our array and separate them by using commas. For example, I'll put in some numbers. 4, 8, 15, 16, 23, 42. So now I have an array that consists of numbers, and those numbers are always going to stay in the order that I've put them there. They're going to stay in that exact order, and that way I can refer to them by position when I want to get them back out. So let's try that. Let's see how we retrieve something from an array. We'll use echo. We're going to reference the variable numbers because that's what's pointing to our array. It references it. And then we're going to use square brackets. And inside those square brackets, we're going to provide the index that we want it to return. In this case, the index will be the position. Let's return what's in position 1. Put our semicolon at the end, and let's bring that up in our browser and take a look. Go back to Firefox, and instead of floats, let's bring up arrays. So there it is. It returned an object to us, and the object that it returned was 8. Now wait a minute. If you go back and you look, 8 is what we would have expected was in the second pocket. And that brings up a very important point about arrays that we must always keep in mind. Arrays are numbered starting from 0. The first pocket is indexed as 0. The second pocket is indexed as 1. It will take some getting used to if you haven't worked with arrays before, but that's how arrays work in almost every single programming language, not just in PHP. So if we change our index to be 0, and then we go back and we reload our page, we'll get back the first item, which is 4. So the first item is indexed with 0. You really want to make sure you drill this idea into your head. The first pocket in an array, the first item in an array, the first value is always going to be referred to by using the index 0. Now, as I said, an array can contain lots of different types of objects. So for example, we can have a mixed type object. We'll call it mixed. And inside there, we'll have an array. And in that array, let's put the number 6, the word fox, followed by the word dog, followed by another array. And in that array, we'll put x and Y and Z. So you see how that works? It doesn't matter what kind of objects we put in there. It can be integers, it can be strings, it can even be other arrays. Any valid type in PHP can go inside an array. So let's now echo back one of those values. Let's do echo from mixed, and let's ask it for what's in number 2. Let's put some BR tags in here just to clean this up a bit. Put one up here as well. And let's also ask it, before we go back and reload the page, for what is in pocket number 3. Now we know what number 2 should be, right? Because we know that they start counting at 0. So you can go down the numbers and say 0, 1, 2, and figure out what's going to be in the second position, the second index. Let's bring that up in the browser and take a look and see if you were right. And it returned dog to us. Now, notice here, we got a notice, array to string conversion is what's happening, and it returned to us array. So when we asked for the third item, they came back and said, it's an array. That's what I see there. I see an array. And it used array to string conversion to try and give us an output for that, rather than output the entire array. Now, if we wanted to see the entire array, we can do that. Let's just try this real quick. Echo, let's look at the array itself. See what that gives us? That comes back and gives us array as well. Instead, it's really helpful when you're working with arrays to use print underscore R. That stands for print readable. And that's a nice way for debugging to see what's inside of our arrays. Now, it's not something we would ever want to show to our users. It's really just for our purposes. With our array, hopefully, we've pulled the data out of the array that we want, and we're not going to run into this problem. But let's just do print R on mixed and see what that gives us back. You see, that gives us something that's readable now. It shows us, this is an array, and here's what that array contains. And you can see the indexes in front of each one. This is index 0, this is index 1, and so on. Even nicer is if you put the pre-tags around it for the HTML. And now, look at that. Now they're indented and everything. Makes it nice and easy for us to follow and see what's inside that array. Now, what if we wanted to get a value out of this array, right? So we're basically looking inside one array, and then from that, pulling another value out of that array. We can do that. Let's just go up here and copy this line. We'll bring it down here. And after we get back the nested array, which is in position 3, then we're just going to ask for what's in position 1 right after it. Square bracket followed by square bracket. Let's go take a look. There it is. It returned Y to us. See how that works? Now I'm just going to get rid of these warnings up here by just commenting these lines out so we don't hit those anymore. Now, what about adding things to our array, right? We were able to pull things out of the array, but we want to be able to assign values into it. We don't want to have to redefine the whole array each time. We can put things into pockets by simply saying mixed, and we'll say at position 2 equals cat. That's it. That's all there is to it. We just say, all right, at position 2, set this value. Put that in there. It's just the simple assignment operator. Let's do another one. I'll just copy this line. And let's say that at position 4, we're going to put mouse. Now, wait a minute. There is no position 4. Position 3 was this item here. So position 4, it's okay to refer to it. It's going to put an item in that 4th position for us. So let's go ahead and take a look. And while we're at it, let's move our print the array down to the bottom. And that will allow us to just see everything that's in there. So here it is. See cat up here and mouse down here in the 4th position. There's also another way. If you don't know how long something is and you just want it to go to the end, you can just make it be blank. Let's do horse. And that will put it at the end. It's appending it to the end. Open up basic. Last index is, this is going to add it to the end of it. Take a look at that. And so there it is. I put horse in the 5th position. So the power of arrays is that a set of information can be referenced by a single variable. Imagine if we have 1,000 email addresses. We wouldn't want to create 1,000 variables for those. Instead, we can assign all of them to an array and then use one easy to reference variable to pull up each email address by its index. The other thing that's powerful about arrays is that they keep their information in the same order unless we change it. Whatever we put in the first pocket stays in the first pocket. So arrays are good for keeping ordered lists. We can sort those 1,000 email addresses and then they'll be kept in that order for us by the array. You can imagine how arrays are going to start helping us when we start pulling records and data out of our database. We can retrieve 50 customer records, sorted alphabetically by last name, and store them in the array. and they'll stay sorted in that array by last name. The one last thing that I want to mention to you is that PHP 5.4, which most of you are probably running, 5.4 or later, has a short array syntax. Instead of writing out the word array, we can just use square brackets to define it. So an array can be equal to square bracket 1, 2, 3, square bracket. This doesn't work in 5.3 or earlier. So because of that, I'm going to stick with the long notation so that anyone taking this training who happens to be using an earlier version won't get stuck. But if I were writing PHP for myself, well, I would definitely use this shorter notation. So it's up to you which one you want to use. Array with the parentheses around it is probably going to start becoming rarer over time, but right now this square bracket is a little bit new, so you aren't going to see it in a lot of older code, especially if they still need to support older versions of PHP. But you should be able to see it in both forms and recognize it as an array. PHP has another type of array called an associative array, and it's important for us to learn how to use both types and to understand the difference between them. An associative array is an object-indexed collection of objects. Now that's very similar to what we saw for the definition of a regular array, but notice that it doesn't say that it's ordered anymore, and instead of being integer indexed, it is object indexed. That is, they're going to be indexed by a label of some sort. Let's remember the expanding file folder metaphor that I gave you when we were talking about arrays. Associative arrays are similar, but they work more like hanging file folders. They're not in any certain order, and they can be rearranged. Each of those file folders is going to have a label on it, and that's how we're going to find information. Since we won't know what order the information is in, instead we will thumb through those file folders until we find the label that matches what we're looking for. Instead of saying, our phone bill is in pocket 1 and our electric bill is in pocket 2, instead we'll say, find the pocket labeled phone bill and pull out its contents. We call the label on each of these pockets the key, and the contents of what's inside the pocket the value. And the combination of the label and the value is referred to as the key-value pair. So we'll always have a series of keys and values that make up our associative array. Both an array and associative array have their uses. When the order matters to us, we want to use an array. When the order is not important, and we want to have the convenience of having a label that we can refer to, well then we want to use an associative array. So if we have 100 customers, we would want to store them in an array. The order of those customers is what matters. But then the information about each customer, I would want to store in an associative array. I don't care that the first item in the array is their first name. In fact, I don't want to have to remember the order in which the data is stored. Instead, I want to be able to ask the array, give me back the information that's labeled first name, and retrieve the data that I'm looking for. So both of them are going to have their place. Let's try one out. So for associative arrays, let's start by opening up basic.html, and we'll do save as, and we'll call this assoc_arrays. Assoc is what I'm going to use for short for association. And make sure you put .php at the end. And here, associative arrays. All right. Now the function that we're going to use to create these is going to be exactly the same as what we had for a regular array. We're just going to use array with the parentheses around it. That is an empty associative array as well as it is a regular array. There's really not a big difference. What matters though is what we put inside of it. So if, for example, inside this array I put first name as a label, that's a string, an object, it's object indexed, and I point that, and I do that using the equal sign and the greater than sign. So it looks like an arrow pointing to the next data, which is the value. So the key is first name, the value is Kevin. And we can have more than one of those. We can have comma, and then last name, again, the arrow pointing to Skoglund. And you can put your own name in there instead of mine. And there we go. That is what an associative array looks like. Instead of being indexed by the position, it's going to be indexed by the key. So if I wanted to get back the first name, echo, then I would do it by saying variable assoc, square bracket still asking for the value using square brackets, and now I need to put the index in here. It's still an index. Before it was an index that was a position, now it's an index that's an object, and the object is the string first name. Has to match exactly because that's the label. I'm looking for first name with that exact capitalization with the underscore in between them. Let's just put a BR tag at the end of that. And let's bring that up in a browser. Instead of just arrays, let's put a assoc underscore in front of it. And there we go. It brought back the first name for us. It looked it up in our array based on its label. That's what it was indexed by. And of course, if we wanted to bring up both first name and last name, we know how to do that using append. I'll put a space, and then I'll just copy this, paste it here, turn this into last name. Bring that up, and you'll see that it brings back both values. Now, assignment works the exact same way that it did when we were working with regular arrays. We have a sock, and then first name equals Larry. That's going to assign Larry to the thing that's labeled, that's indexed by first name. And then let's just echo it again so we can see the results. You can see now it's changed it, and the value is equal to Larry in there. Now, numbers don't work anymore. So for example, if we were to come down here and we were to ask it for what is in position 0, and let's bring that up. You see it comes back and says, oops, undefined offset, right? Basically, I don't have an index called 0. I'm looking for 0 and I don't see it there. So that's not going to work. That is, unless you indexed it by using numbers, right? Any object can be there. It doesn't have to be a string. We could use a number. So in fact, what you'll realize is that this array that we had, numbers, 4, 8, 15, 16, 23, 42, is exactly the same as if we had this associative array written out. 0 points to 4, 1 points to 8, and so on. It's the exact same thing. Let's just bring that up in the browser, and you can see that it brought up 4 for us. It returned this value because it's indexed with this. So in fact, there's not a lot of difference between an array and an associative array, except that we have the convenience of not putting each one of those numbers in there when we're just concerned about the order. So you can see that in fact, an array and associative array actually have a lot in common. They're really built the same way inside PHP. It's just that when we write it in this form, we aren't providing the indexes. We're assuming that it can be derived from the position of the items. Whereas here, we're actually specifying what each one is. And if we wanted to make this one into 20, that's perfectly valid. We can do that. We can say that the index of it would be 20. It's not 2 anymore, it's 20. So arrays are going to play a big part in programming, so it's important that you make sure that you understand them. If this didn't make sense at first, then watch these 2 movies again and make sure that you have a good foundation on what they are and how they work before we move on. After that, we'll go to the next movie where we'll look at some functions that work on arrays. In this movie, I want us to talk about array functions. And there are a lot of functions for working with arrays because arrays are super useful and we're going to use them in a lot of different contexts. And there's lots of things that we might want to do with them and ways we want to manipulate that information. So we're going to look at a few of the most common ones, and then I'm going to show you how you can look up the rest of them. To start with, let's create ourselves a new file for this. And let's make our basic.html file saved as, we'll call this array functions.php. There we go. Inside sandbox, array functions. So to start with, I'm going to paste in a numbers array, which is the same numbers that we were working with in the last 2 videos. But the difference is that I've jumbled them all around. They're not in the same order anymore. And that's because one of the things that we're going to be looking at is how we can sort those numbers. But before we do that, I want to look at a couple of other ones. The simplest one, of course, is just that we can count those values. We can use count to tell us how many items are in the array. What's the size? What are the number of items that it contains? There's max, which will tell us the maximum value, and min to tell us the minimum value. That's very handy, especially if we're working with math, and we want to make sure that we take something that's always the maximum of several choices or the minimum of several choices. Let's bring those up in a browser and take a look. Let's save that and go back to Firefox. And instead of associative arrays, we're now going to be looking at array functions. So 6 values in there. The maximum value is 42. The minimum value is 4. As I said, we can also sort those values. Just make my window a little bigger here. So I'm going to sort them. And then right after I sort them, I'm going to use print r to output it so that we can see the result. So sort and then output it. And then rsort is for reverse sort, and we'll output the result of that. Take a look at what each of those give us. So reload this page. So sort and then reverse sort. If you'd like, you can put PRE tags around those to make it easier to read. Let's do that real quick. There we go. You can see that sort returned them in ascending order, whereas reverse sort returned them in descending order by value. Now there are rules if these aren't numbers as to how they get sorted. Obviously, if you were sorting a bunch of strings, it would sort them alphabetically by the first letter, and then the second letter, and so on. If you were sorting an array that had a mixture of things, it would sort them for you, but the sort order might not be what you'd expect, because whether it sorts a letter before a number or a number before a letter is a little bit arbitrary, and you'd have to look that up in PHP to see which one it was going to do. So you typically wouldn't do it in that case, but it would go ahead and handle it for you. Notice one thing about sort, which is that it actually sorted the array in place. We didn't do any kind of assignment. We didn't have to say numbers equals a sorted version of that, right? It changed it in place. It's a destructive function. So our old version, our old unsorted version, doesn't exist anymore, right? It sorted them in place. Another handy function is how we can turn an array into a string. In other words, combine values together to get a string. And we can do that with implode. So what we do is we say what array we want is the second argument. The first argument is what the separator is between each of those elements. So here I've said it's a space and an asterisk and a space. I'll save that and you'll see what it looks like. Let's just do an echo on that so that we can see it. And you'll see that it imploded it. Now it's 42 star 23 star 16 star, right? It's not an array anymore. This is a string. We could do get type on that and we would see that it was a string now. The opposite of implode is explode. So explode is going to take a string like numString, and every time that it finds this string, it's going to use it as a divider between the values. So every time it sees space asterisk space, it's going to say, all right, that's where I need to split this into a new object in the array. So we can see what it does here. Let's come back, return, and you can see that here's the array. It divided it back up into each of the values. It took this string and said, all right, 42 is the first value. This is a separator. 23 is the next value. This is a separator, and so on. This is extremely useful when you're working with something like a comma separated list, right? So you have first name, comma, last name, comma, address, comma, city, comma, state, comma, zip, that sort of thing. Well, you can break that up into an array by telling it to explode it based on where the commas are. Another useful thing to be able to do is to be able to tell whether or not something is in an array or not. Does an array contain a value? So 15 in an array, echo, does the array contain the number 15 inside numbers? And it's going to return true or false. Is 19 in the array? And it's going to return either true or false for whether 19 is inside the array numbers. So in_array is what allows us to do that. Let's save that. Try that out. So 15 in an array? Yes, it is. True is represented by 1 here. 19 in an array? No. False. False is represented by having nothing there. Now, as I said, there are many, many functions for working with arrays. If you go to the php.net website, so php.net/manual and then your language, en/ref.array.php, here's array functions, and here's a whole long list of them. You can see I could just scroll down the list here. There are a few that I think are especially interesting. There's array keys that returns just another array of only the keys from an associative array. And then there's the same thing for array values down here. Returns just the values. So if you have a key value pairs, you can just grab all the keys out of it or all the values out of it. Array push is an interesting one. That allows you to push an element onto the end of an array. Array pop does the opposite. It takes an element off the end of the array. Array shift is what you would use to put an element onto the front of an array. And array unshift is what you would use to take it off of the beginning of the array. Array unique will make sure that all of the items are unique in the array. It takes out any duplicates. There's array search up here. That searches the array for a given value and returns the corresponding key if it finds it. So it's a value search through your array. And then array random is also nice. Array rand, _rand. This can pick one or more random entries out of an array. So each one of those you can click through, you can look for the documentation on it, you can surf around these. If you're working with an array and you're not sure how to accomplish what you want, this page may provide the answers that you're looking for. In this movie, we're going to look at Booleans. A Boolean is a programming type that can either be true or false. That's it, one of those two values. And true is not the string true or even the number 1, it's just simply the value true. Booleans are very useful in programming because we can use them when performing tests. For example, in the last movie, we used the inArray function to test whether an integer was inside of an array. The result was that the test was a Boolean. True if the integer was present, false if it was not. Let's start by creating ourselves a new workspace for this. I'll open up basic.html. We'll do save as. We're going to call this Booleans. Notice how that's spelled, B-O-O-L-E-A-N-S. And I'll also call it Booleans here. And let's create our PHP tags. Now a Boolean is simply the value true or the value false. Notice that there are no quotes around that. It's not a string. So we could have, for example, result 1 equals true, and then down here we'll have result 2 equals false. Now all we're doing is assigning a Boolean to a variable. We can assign it just like we do anything else. And we can take a look at what these values look like when we echo them back. I'll just save that, result 1 and result 2 being echoed. So we'll just go to our browser, and instead of array functions, let's now load up booleans.php. Notice that result 1 comes back and says 1, result 2 doesn't have anything. We've seen this before. 1 is what happens when PHP converts a Boolean true into a string. It turns it into 1. When it's converting a Boolean false into a string, it has nothing. It outputs absolutely nothing. Not a 0, but actually no string at all. Now we can assure ourselves that result 2 is in fact a Boolean by calling another function here called is_bool. That will tell us whether or not something is a Boolean. It's just like we had is numeric earlier, is float. Well, we have is bool to find out if something is a Boolean. And what is it going to return to us? A Boolean. But the difference is that if result 2 is a Boolean, it's going to return true, which we'll be able to see, because that'll come back as being a 1. Now notice that I have true and false all lowercase here. In PHP, you'll often see it written all uppercase, true and false, or you'll see it lowercase. And you can waste a lot of time arguing with people about the right way to do it in PHP. Everyone has their belief about whether they should be uppercase or lowercase, but in truth, in PHP they're case insensitive, and you can use whichever one you prefer. They're absolutely equal. I prefer to use the lowercase version. Now where Booleans are going to be most useful to us is when we're working with conditionals, which we haven't seen yet. But the basic idea is that in our code we want to say, well, if one thing is true, then do this bit of code. If something else is true, then do this other bit of code. I'm going to give you a little sneak peek of conditionals. Even though we're not quite ready to really dive into them yet, I'll go ahead and give you a preview. Let's say that we have number equal to 3.14, and we're going to write an if statement. Don't worry too much about the format of the if statement. We'll be covering this later, but I'm going to check to see whether number is a float, right? We saw that is float earlier, and it returns a Boolean as a result. So if it returns true, then echo it is a float. There we go. Let's just try that out. And there it is. You see that it is a float. And if we change it so that it's not a float, make it a 3, we reload the page, you'll see that it doesn't execute that code. So that's where Booleans become really useful, is when we're working with conditionals. And we're going to do a lot of that when we're programming. So we'll see more of that when we come to the conditional section. For now, just make sure that you understand the basics of what a Boolean is, and that a Boolean is not a string or an integer. It is its own type, and it's always either true or false. In this movie, we're going to be talking about null. Null is a fancy term for nothing, for not having a value. It's not 0, it's not an empty string, it's the actual lack of a value. I mean, if we can set a value into a variable, then we also have to have some way to talk about the fact that that variable might not have a value at all. And null allows us to do that. Let's take a look at it by first creating a page where we can work with null. And I'm going to do that by opening up basic.html and then choosing Save As. We're going to save this as null.php. So null. Now, like true and false, the Booleans that we just talked about, null can either be written in lowercase or in all uppercase. And you will waste a lot of time arguing with people about the right way to do it in PHP and whether one is better than the other or one has better performance than the other. But the truth is that they're case insensitive and that you can use absolutely whichever one you prefer. There is no difference. I'm going to use the lowercase version. Now let's set a variable equal to var1 equal to null. And just for contrast, let's set var2 equal to an empty string, just so that we can see the difference between those two. Now, like a lot of the other types that we've looked at, there are functions that allow us to test whether it is of a certain type. So we can test whether this is null or not. Is_null will tell us if the variable is null. And we'll do that to both of these. Let's also do it to a third one as well. Make this var3, and we'll test var3. Now var3 isn't set, right? It hasn't been set to anything. So we'll see what that gives us back. Switch over to Firefox, and instead of Booleans, we'll load up null.php. So it came back and said, is variable 1 null? Yes, it is. Variable 2, is that null? No, it's not. That was my empty string, so that's not considered null. Var3, is it null? I get a notice here That's not an error. That's not a warning. It's a notice just saying, hey, little heads up here. You're in the middle of developing, and I noticed that you're making a reference to an undefined variable. So I want to call your attention to it here. Notices are different than warnings in PHP. But it goes ahead after that notice and gives us the result, which is that yes, in fact, var3 is null. The fact that it hasn't been set means that it has no value. So the answer is true. It is null. So notice the difference between that. Notice what happened with var1 and what happened with var3. By setting it specifically to null, I avoid this notice that pops up. And we can contrast that with what happens if we have is set, right? So let me just paste in a few others here. var1 is set, var2 is set, or var3 is set. Is set doesn't have a space here, no underscore between is set. It's all run together. And let's just reload the page now. And you can see that it tells us that variable 1 is not set, variable 3 is not set, and variable 2 is set. Now, not set means that it's null, right? So being null, we're being told it's the same thing as being unset. Now we know it's not exactly the same thing. We saw that with is null, but it's close. For the purposes of most of our tests, it will be the same. So that's what null is. Null is just the lack of having a value. That's a pretty easy concept. But I think this is also a good spot for us to talk about a function in PHP called empty. And as you'd expect, empty returns a Boolean, true or false, for whether a variable is considered to be empty. What you might not expect, though, are the things that it considers to be empty. In PHP, empty is going to be an empty string, null, 0, 0.0, meaning a float in which the value is 0, a string with a 0 inside of it, false, or an empty array. All of those things are considered empty. So we can provide our tests again here for whether these things are considered empty. Let's define var3 here, just so it has a value. var3, oops, need my $sign in front. var3 is going to be equal to, and let's make it 0 inside the string like that. Let's come back over to our browser and let's try those out. Let's see what things are empty. Is var1 empty? Yes. var2 empty? Yes. var3 is empty also. So null, an empty string, and, this is a very important one, 0 inside the string are all considered to be empty. Now this broad catch-all approach can be extremely useful, but you have to use it with a lot of caution. For example, imagine that you had a web form that was submitting a value to your PHP code. And imagine that that field was, how many children do you have? You want to check if that field is left blank by the user. And if not, you want to say, hey, you need to fill out this. I need to know how many children you have. Empty would detect an empty string or no value being submitted, which is what you want. But it would also not allow the number of children you have to be 0 as a value, which is probably not what you intended, right? They would not be able to submit the value 0. Just like we saw here, that would be considered empty as well. So most times you'll need to use further conditions with empty, such as, is it empty and also not numeric? Or is it empty but not null? Now I'm mentioning this now because empty is a leading cause of bugs in PHP code. So it's something that you're really going to want to keep an eye out for. During the previous movies, we've been looking at different types in PHPs. So strings, integers, floats, those are all called types. And we've seen a few times when PHP converted a value from one type to another type for us. For example, we were able to add a string to an integer. And we saw that PHP converted a Boolean true to be the string 1 when it was output to our web page. This process is referred to as type juggling when PHP does it on the fly for us. We can also explicitly set a type ourselves. For example, converting a string 1 into the integer 1. And when we do it, it's called type casting. And we can do type casting in two ways. We can do it using a function. We have the set type function for that purpose. And it's just set type, and then in parentheses, 2 arguments, the item that's being cast into another type, a comma, and then the second argument is the type that we want to set it to. So in this case, it's going to either convert var to be an integer or make sure that it already is an integer. Notice that integer is in quotes. It's a string that we're passing in. The other way that we can set type is by simply writing the name of the desired type in parentheses before the item being cast. So for example, parentheses integer, close parentheses, space, and then the item that we want to cast. Notice that there's not quotes around integer in this case. We're just putting integer right there between the parentheses. It's not a string, it is just an instruction to PHP. And this is the syntax of how it's done in the C programming language. That's where this comes from. The types that we can use, the values that we can provide for typecasting are the different types that we've seen so far. You've got string, integer, or int for short, float, array, Boolean, or bool for short. Now for some of these it's going to be kind of obvious if we're converting an integer to a float or an integer to a string. It's pretty obvious the kind of conversion that it's going to make. But it's probably less obvious to you if you're going to convert the number 42 into a Boolean or convert an array to a string, what that kind of result is going to give you. You can try them in an experiment to see so you get a feel for what they do, or the php.net website actually has a list of the rules that explains how it converts from one type to the other. And so you can look those up. Let's create a page where we can do some experiments and play with both type juggling and type casting. So let's start by opening up basic.html, and we'll do save as. I'm going to call this page type_casting.php, even though it's technically going to be for both type juggling and type casting. Type casting is probably the more common term that people use to refer to it, mostly because it's the thing that we have control over. So let's start out by just putting type juggling in the HTML here. And then let's put a bit of PHP in. We'll define count is going to be equal to a string that is 2. Okay, so it's equal to a string. And we can find out what type it is. We can certainly use isString, isInt, those kinds of queries that we learned when we were learning those types. But an even better way to do it is to put echo get type. So we're going to just ask it to get back the type of count for us. I'll put a BR tag at the end. So that's going to report back. Now we know what the type of that is. It's pretty obvious. The type is a string. Even though it's a number, it's going to be a string. So now let's do a little bit of PHP, and let's add count plus equals 3. We saw this before when we were looking at integers. So let's do get type again, and then let's just bring up that page so we can have a look. Here we are. Instead of null, I need type_casting.php. So type juggling starts out being a string, and then it converts it to an integer. So count got converted when we added +3 to it, right? The type was converted. It knew, even though you started with a string, if I'm going to add these two things together, I'm going to need to have integers. And so it does the conversion for you. That's type juggling. PHP tries to make it work out for you. And we saw that if we had 2 cats, for example, that the same thing, reload the page, it still works just fine. It still goes ahead and adds them together. We could output the count and you would see that it was equal to 5. Now I can also see type juggling going back the other way. Let's convert our integer back to a string by concatenating it with 2 other strings. Here I have cats equal to a string followed by what is now an integer. Remember, we ended up with an integer here, and then another string. And when we get type on that, we'll see what that returns to us. Let's bring this up, reload the page, and it's back to being a string again. And that's because it said, hey, I'm going to concatenate a string, an integer, and a string. Well, if I'm doing concatenation, I need to turn those all into a string. And so it juggles it back to a string for us. Now, I think that this second one, using an integer to a string, is not such a bad thing to do. And I think you'll see that happen a lot in people's PHP code, because the conversion from an integer to a string is super simple, right? And it's something that we're probably going to be doing a lot. However, I think in other cases, like here, when we're converting a string into an integer, or especially if we're doing more complex conversions, maybe you're trying to convert an array into an integer, right? That seems like a much more extreme example. It's sloppy programming to rely on PHP to do the switching for you. It's much better for you to make the change yourself. So I wouldn't say that you can never do type juggling, because I think you'll find me doing this kind of thing in my code all the time, but you won't find me doing this kind of thing in my code. I think that's the kind of thing in my mind that would be considered sloppy programming. So how do we make the change ourselves? Let's give ourselves a BR tag here, and then let's do type casting BR. So we talked about the 2 ways that we can do type casting. One is to use a function. So we have the setType function. We're going to go ahead and use that same variable count, but this time it ended up with a string here. Now we're going to change it back into an integer. And we can do get type on that and see what that is. Let's just bring that up and try it real quick. There you go. It cast it back to an integer. It was a string. Here we changed it back to an integer. The other way that we can do it is by using that declaration in front of it, right? String in parentheses. This is not a string itself. It's just the word string inside parentheses right before count. And I'm setting count2 equal to that value. And then we can compare. We can see what count equals and what count2 equals. So let's bring this up and let's try it. There we go. Now notice count1 is still an integer. Count2 is a string. And this is an important point about the difference between doing it these 2 different ways. SetType changes it in place. It actually just affects the variable right where it is and changes its type. It recasts it in place. This one does not do that. And we could actually, if we take this away, you would see the difference and you would see that it doesn't recast it. Let's make that point a little more explicit. Let's just make a BR tag here, and I'll do PHP $test1 is equal to the number 3. And then we'll do that same thing, but we'll make test2. So we'll have two of them. They're absolutely identical. And then let's set the type both ways. So let's try the first one. We're going to use set type, and we'll do it to test1. And its type is going to be string. We're going to explicitly convert it. Then in the next one, let's just do it by putting string and then test2. Okay, see what I'm doing? I'm just setting the type both ways here. Now, let's test the type for both of them. I'll just grab one of these lines up here, use that as a starting point, but we're going to call it test1 and test1. We'll echo back that value and then do the same thing for test2. Okay, so let's bring that up and let's take a look. Reload the page, and you see the first one was changed to a string. The second one was not changed. It still is an integer. This change did not last. It only takes place as it's being used. In this case up here, as it's being assigned. The conversion is happening during the assignment. It's not making a permanent change to the item itself. So it's important for us while we're programming to be aware of what type something has. Is it an integer or is it a string? And then to use typecasting when we need to convert it to something else. We started off this chapter by talking about variables. So it's fitting that we're going to end it by talking about constants. As you can guess from the name, a constant is the opposite of a variable. A variable can change or vary. A constant can't change. It remains constantly set at the same value. Constants are going to be recognizable in PHP because they're always written in all capital letters and there's no $ in front of them. They're also going to differ from variables in another way. The only way to set a value for a constant is to use a function, the define function. You can't just use the equal sign to assign a value like you can with variables. Let's try some experiments. I'm going to open up basic.html, and then we'll just do save as, and we're going to call this constants.php. Change the title here to constants, and let's give ourselves a PHP block. Now we know how variables work. Let's say we had max width equals to 980. That would be a variable set at the integer 980. But if it was a constant, max width would not have the $ in front of it, and it would be in all capital letters. So it would be max underscore width. Now if we wanted to set max width to 980, we can't do it by just simply saying 980. That doesn't work with constants. Because we're going to be doing them only rarely, we need to use this special function to do it. We're going to use define, and then we're going to provide the name of the constant in quotes, max width. The second argument then will be the value that we want to set it to. So that's going to define max width for us. Now notice that we use the quotes here, but most of the time when we talk about the constant, we don't use the quotes. Why don't we use them here? Well, if you think about it, this is a constant. But how can we use a constant if it hasn't been defined yet, right? So we have to use quotes until it's been defined. We're just providing PHP with the string that we'd like to use for the name of it. So don't let that trip you up. Now, once it's been defined, then of course, we can echo back the value and see that it's been set. Let's just do that real quick. I'll save that and we'll switch back over to Firefox. And instead of typecasting, we're looking for constants. So there it is, 980. That's the value that's being echoed back as max width. Now we can't change the value. Let's just see that real quick. I'll put a BR tag and then let's open some more PHP. Let me make a note here. Can't change the value. Max width plus equals 1. And then let's echo back max width. See what we get. All right, let's switch back over to our browser. Reload it. Oop, sorry, error. You can't do that. There's syntax error. We can't do adding to this, right? Max width equals max width plus 1. That doesn't work either. Let's just switch back and try it. Nope, sorry, can't do it. So let's take both of those out. Let me show you that you also can't even redefine it. All right, so let's just drop down here. We defined it here. Let's just change this and let's say can't even redefine it. So let's say instead of 980, let's make it now 981. Let's try and echo that back and see what we get. It says, oops, sorry, constant max width was already defined. And then what value did it give me back? 980. It didn't change anything. It basically just objected to this completely, said, sorry, can't do it. And so max width stayed unchanged. It stayed constant. Now a constant stays defined for the duration of the PHP script. So of course, once the script ends and all the values are unset, then it can be redefined on the next run of the script. So think back to that diagram that we had of the request response cycle, right? When it comes in and it first grabs our script and executes it, it defines the constant stays defined until it returns HTML to the user, but at that point, the constant goes away. Everything in our PHP goes away at that point until the next request response cycle. So I don't want you to think this value is forever set in stone. However, during one execution of your PHP script, that value is going to be defined and it is going to be fixed. Typically, you're only going to use them for things that don't change, things that you really want to be hard and fast. Maybe you're going to define the root path of the place where you're going to store images, right? So you want to have that as a fixed location on this hard drive. This is where you can find your image storage. That's the kind of thing that you would use a constant for because you're not going to be varying it. You want PHP to have a fixed location for those. So most of the time you're probably going to want to use variables and you're going to use constants sparingly, but they're going to be very useful for saving data that's fixed. In this chapter, we're going to be looking at how we can start to control the flow of our code, to have our code make choices about what should happen based on certain conditions. And we're going to do that by using logical expressions. And the most common of all types of logical expression is the if statement. This is the basic format of an if statement in PHP. You've got if followed by, in parentheses, an expression. And that expression is going to evaluate to either true or false. It's going to have a Boolean result. So if the expression is true, then the statement that follows it will be executed. If it evaluates to false, then the statement will not be executed and the code will skip past it and keep on evaluating down the rest of the PHP after it. So for example, if we have if A is greater than B, then echo back A is larger than B. So if the expression A is greater than B evaluates to true, then we'll get something echoed. If it's not true, then the echo line will never execute. PHP will just ignore it and move right on past it. Now this format that I'm showing you here works if the statement portion that's going to be executed is just a single line. If you have more than one line of code that you want to execute for the statement portion, then you'll want to use curly braces around that statement. This makes it clear that everything inside the braces should be executed if the expression evaluates to true. It's required for multi-line statements, but it's also considered a best practice to add them around single-line statements too. It's clearer, and I also think it's easier to develop using one style and just to stick with it. So always use curly braces. Notice also that I've indented the statement portion. PHP doesn't care about the indentation. Remember, white space doesn't matter to PHP. But indentation is going to help us a lot because it's going to improve code readability. It's also going to help me to make sure that for every opening curly brace, that I have a matching closing curly brace. And when we start nesting these inside of each other, it can sometimes be hard to tell and easy to lose track of them. So let's start with those two good programming habits, always using curly braces and always indenting our code. Let's try some if statements for ourselves. So here I am in my sandbox, and I'm just going to open up basic.html. I'm going to choose save as, and then I'm going to call this logical.php and save that in my sandbox. Logical. So let's just try the example that we just saw there. So we have PHP, and in it we're going to define A is equal to 4, and let's have B and have that be equal to 3, and then we'll write our statement. If A is greater than B, use my curly braces. Notice that it indented for me. TextMate does that helpfully. Echo A is larger than B. Okay, so that's my statement. Let's go and try this out and see how it works. Switch back over to Firefox, and I'm going to be going to localhost, Kevin Skogland, and sandbox logical.php. A is larger than B. Now you can play with those values, and we can say, all right, let's set these in reverse. Let's go back, and let's reload the page, and notice that it doesn't output anything. It only evaluates what's inside the curly braces if this statement is true. Right? Simple enough. All right, let's try some more maybe real-world examples. something a little less experimental. Let's say that we have a website and we want to have a special welcome message that displays only to new users of the website. So we determine whether someone is a new user or not. In this case, I'm going to say that it's true. If that is true, then we're going to display this welcome message to them. So we can experiment with that. You can try this from true to false and back again. But let's just go over here, try it out in our browser, and you'll see that we get our welcome message because it was true. Another good example, you remember that we talked about that you can't divide by 0, that gives you problems? Well, here's a way to check that. We have our numerator that's 20, the denominator is 4. If the denominator is greater than 0, then it's okay to proceed with the division. If it isn't greater than 0, then we may have a problem here because this can't be 0. Now I realize that this doesn't account for negative numbers, but you still get the point. You see what I'm saying? That it is not letting you divide by 0 before it gives you the result. Let's just try that one out real quick. It says no problem. I can go ahead and I can do that division. Now notice that the echo for result is occurring inside this if statement. I just want to move that out of there so that you see what happens if I do this. All right, so it doesn't do the division, but it's going to echo then the result here. Let's go back and see what happens when we load that up. It works just fine, but if I now make the denominator into 0 so that it would not execute this statement, right, because now this fails, this is false. Let's come back over here and let's reload the page. And you'll see, oops, undefined variable. And the result, no result there. So notice that the result is being defined in the if statement. That's an important point. If we're defining variables in the if statement, then we need to make sure that we account for the possibility that result is not set. All right, so we're going to start with a result of 0, and then that way result will still have a value because this code does not execute at all if that statement is not true. So you'll want to watch for that. Think about this sort of path through your code. If the if statement doesn't execute, none of the variables and assignments that you make in there are going to be available to you. Okay, let's go back up here to the top, and you see that we've got this if A is greater than B. So if we wanted to account for the possibility that if A was less than B, we could say A is not larger than B, right? And that would work. However, there's a better way to do that than to just do a series of if statements one after the other. And we're going to see how to do that in the next movie. In the last movie, we saw the basics of an if statement and how we could have a section of code that only executes if an expression evaluates to true. In this movie, we're going to build on that by talking about else and else if. That is the ability to have an alternative that gets executed if something is not true. Let's take a look. So if we have if A is greater than B, we want to echo A is larger than B, we can use else immediately after it to say if that's not true, then the alternative version should be to echo this section of code, this statement, echo A is not larger than B. So one of these two things will be true. We've basically divided the path into two and said, if this is true, do the first statement, else do the second statement. Now, again, this is without the curly braces, which is suitable if you have only a single line of code, but I'm going to strongly encourage you, even if you have a single line of code, to always use curly braces. And if you have multi-line code, you'll definitely want to use them. I think it's a good habit to be in. Now, I do want you to see that it is a binary choice between these. It's going to do one or the other. Once that first test passes and its statement is executed, the rest of the options below that are skipped over. It jumps to the very end of this whole statement, down to the very final curly quote, and that's where it picks up and keeps executing. So if A is greater than B, echo A is larger than B, and then jump down to that final curly quote and proceed from there. It doesn't continue checking for additional options. Once it finds one, it's done. It's done with this whole entire statement. Now, in addition to just else, we also have else if, and that lets us string multiple conditions together. So we could say, if A is greater than B, then echo A is larger than B. Else if A is less than B, echo A is smaller than B. Notice before I said not larger because there's the possibility that the two are equal. So now I can say else if, do another test. So if the first one matches, it'll do the first statement. If the second one matches, it'll do the second statement. If A and B are equal, well then neither one of these are going to execute, right? Neither one of its conditions were met, so we'll just keep going from there. And of course we can combine all three of these together so that if A is greater than B, we echo A is larger than B. If A is less than B, we echo A is smaller than B. Or the final catch-all is the possibility that A is equal to B. It's not greater than, it's not less than, it must be equal to. So when we only have two, else is the alternative version. But if we have multiple ones, then else is sort of the default. It's the final thing. If none of these other conditions matched up above, this is the final result that you ought to do. Let's go back to our page and try those. So I'm going to go back to the same page that I was working on before. That's the logical.php. We'll just do it on this same page. Notice before that I had two if statements. If A is greater than B, or if A is less than B, I can now convert those. And I could do it by using else and say else A is not larger than B. Or the other way to do it would be, let me just back up and undo that, to change this to say else if A is less than B, A is not larger than B. Now that's not quite true. It's A is smaller than B in that case. And so then we can add that final condition, which will echo A is equal to B. Now once again, if A is greater than B, this bit of code gets executed. After that, it jumps right down to here and keeps executing our PHP. If this one's not met, then it goes to the second one. If that's not met, then it goes to the third one. But after each one of these, after each determination is made, that block gets executed, and then it jumps down here to continue with our PHP. So the combination of these three, the ability to have if, else if, and else, really gives us lots of control over the flow of our code. We can now start to fork our code and say if a new user is true, well, give them a welcome message. If they're not a new user, give them a different message. If they are a user type of student, give them one thing. If they're a business, give them something else. If they're a consumer, give them something else. And we can start nesting these inside of each other as well, so that if they're a student and they also are enrolled in a special program, we give them a different message. You can really start to see the important role that logical expressions are going to play in programming with PHP. In the last movie, we learned about basic logical expressions using if, else, and else if. Now I want us to talk about the expression part of that, the part that evaluates to true or false. And I want us to enhance our ability to work with that to generate some more complex expressions. And to do that, we're going to have to learn about comparison and logical operators. In the previous example, we said if A is greater than B or if A is less than B. Less than and greater than are comparison operators. But there are a number of other ones that we can use as well. One of the most important ones is equal. Are two things equal? Compare them. Is A equal to B? It's made up of two equal signs. When we're testing if something is equal, we do it by using two equal signs. So when we have one equal sign, we're doing assignment. We're assigning a value to something. When we have two of them, we're comparing the two. It's important to keep the two straight. One is for assignment, two is for comparison. We also have another version, which is three together, which is for identical. Now, what's the difference between equal and identical? Well, there are some things that are considered equal because they're roughly equal. For example, the number 1, 2, 3 is considered equal to the string 1, 2, 3. Because if we convert the types, then they're considered equal. But they're not considered identical. Identical, they have to be of the same type as well. So it goes just a little bit further in the check to make sure that they're absolutely 100% the same. Most times you're going to find yourself just using equal though, with two of them. There's also comparison. We saw the greater than and less than. There's a greater than or equal to, or less than or equal to, or it's either less than or greater than. And of course, if we're going to do not equal to, we can also just simply say not equal using exclamation point equal. That exclamation point is going to mean not in PHP. We're going to see that again later on. And then of course, we also have not identical, which would be not followed by two equal signs. Notice that in each case, for equal and identical, what we're doing is replacing the first equal sign with that exclamation point. Now, in addition to using these to construct a single expression to say, is this equal to that, or is this greater than that, or this not equal to that, we also can combine several of these together by using some logical operators. So for example, for and, we can use two ampersands together. What we're saying here is if A is greater than B, and if C is greater than D. We're testing two different things and combining them with this and. Both parts of it have to be true. If this is true and this is true, then the whole expression evaluates to true. We also have or. That's made of these two upright bars, often called pipes. Take a second to figure out where that is on your keyboard. It's typically right above the return key. And this would be a logical or. So if A is greater than B, or if C is greater than D. And then of course, as we talked about, there's not. So if something is just not true, we can negate the expression just by putting the exclamation point in front of it. It basically just flips it around to be the opposite. Let's try a few examples. Let's start by just opening up basic.html, and we'll do a save as. I'm going to call this one operators.php. And it's going to contain both our comparison operators and also our logical operators. Let me just drop down here in the body and I'll give you the first example. You can pause the movie if you need to copy this down. I've got A equals to 4, B is equal to 3, C is equal to 1, and D is equal to 20. Notice that those are assignments using the single equal sign. Then I've got my expression here. If A is greater than B, notice that I'm using parentheses around it to group it together, and if C is greater than D. So if both of those conditions are met, this and this, then this entire expression will evaluate to true because both parts have been met. So both trues together mean that the whole thing is true. If either one is false, well then it's not a true statement. It's not true that both A is greater than B and C is greater than D, so that it evaluates to false. So let's just try this out. Let's bring this up in a browser, and instead of logical, we're going to go to operators. You'll see that nothing is output. The reason why? A is greater than B, but C is not greater than D. So let's just swap those real quick. We'll go back and try it again. There it is. A is larger than B and C is larger than D. So we can do the same thing with logical OR by just putting in the OR, and I'll just change this as well. So now either one is true if A is greater than B or if C is greater than D. If either one of those is true, then it will work. Let's just flip this back to what didn't work before, right? So now one of them is true. A is greater than B, but C is not greater than D. Let's go back and reload it. So A is larger than B or C is larger than D. That's what it output for us. So as I said, we can also use some different comparison operators. We could say that one thing is equal to something, that something is equal to that. You can feel free to play around with those and try different values and see what you're going to get back. Let's try a real world example. I'm going to do one here for if, and I'm going to use the not, right? The exclamation point. That means not the case. If is set, and I'll make it E. If not is set, right? That's the opposite. If it's not set, then we're going to set E equal to 200. And then let's just echo back the value of E. I'll put a BR tag here just so that it separates it out. So let's try this. Let's see if it outputs something for E. Switch back, 200. Now let's experiment here. Let's set E up here as well. Let's set E here equal to 100. Okay, so let's go back and try it again. Now it's equal to 100 because it got here and it said, oh, it's already been set. So I don't need to give it a default value. This is a good way to set default values. If something's not set, well then set it. Let's do another good real world example here. Let's do one with empty. We talked about empty and I said you have to be really careful when you're using empty. Let's say that we have a form coming in and we don't want to reject 0 or 0.0 as being valid values. Well, we can say if the quantity entered is empty and if it is not numeric, then we say you must enter a quantity. But if they've given us empty, but it is numeric, right? It fails this part of it, then it's probably a 0 or 0.0 and we'll allow it through. Let's just try real quick, quantity, and let's just set that equal to 0. And we'll add another BR tag here just so it'll separate it out nicely. So there it is, it didn't respond to it, but if we said, for example, that it was a blank string, now we go back, we reload it, it says, you must enter a quantity. There's also the powerful combinations that can be made here. You can nest different logical operators together. You want to use parentheses to help you group those together so that you can keep them straight. So while these comparison operators and logical operators are really simple in themselves, they combine to develop some really powerful expressions. We can keep stringing them together, we can nest them inside each other, so that if all sorts of conditions are met, if the final evaluation is either true or false, we'll decide whether or not we execute some code. And that's going to be a powerful thing. In this movie, we're going to be looking at a different kind of logical expression called switch statements. Switch statements are similar to if statements in that they control the flow through our application, but they're going to have a different syntax, some different rules to follow, and a couple of special gotchas that we want to make sure that we watch out for. First, let's look at the basic syntax. We're going to use the function name switch followed by an argument, and that argument is going to be a value. This is the value that we're going to be testing through each of a series of test cases. So then in our curly braces, we're going to list off those test cases, and each one is going to start with case, and then a test value that we're going to test against value to see if they're equal, and then a colon, and then a statement or series of statements that we want to execute. Then following that will be the next case that we want to test. So we'll test whether the value is equal to test value 2, and if it is, then we'll execute those statements. And then finally, we have the option to provide a default case. If it doesn't match any of the above cases, we're going to execute the statements that are defined by default. So notice that we're dropping down each one of those cases, doing a test on each line. It's very similar if we'd written if, elseif, and else. The big difference here is that we're testing equality. We're testing to see, is the value equal to test value 1? No? Okay, move down to the next one. Is value equal to test value 2? But it's a very simple comparison of equality. There's no greater than or less than or anything like that. And usually we're not working with Booleans because a Boolean is either true or false. So there's really not a lot of test cases. Where you would see it more is if you had something like a string that could be many different things. For example, let's say that our customers had told us that the way that they wanted to be contacted, and they might have said that they wanted to be contacted by email or by phone or by some other method, text message, Skype, something else. So we could have a switch statement that then executed a set of statements based on the way that they told us they wanted us to contact them. Now I've only provided 2 case statements here and a default, but you can have as many cases as you need. You can just keep adding different cases each time. Now most times you're probably going to want if-else statements. You're going to use those way more often than switch statements. But switch statements are going to be very useful when you do have this kind of compact logic where you really are just saying, all right, I want to test a value, and that value can be 10 different things. So I'm going to list off the 10 different things that could happen if that value is each of those 10 cases, and I'm going to provide code for those. The parallel structure can be a little bit easier to read and to work with. Okay, now that we know the syntax and the basic idea, let's try some out. I'm going to create a new page where we can work with these. I'm going to open up basic.html, and I'll do save as, and I'm going to call this switch.php. Change the title to also be switch, and let's give ourselves a PHP area. All right, so to start with, let's just give ourselves a variable. We'll call it a, and we're going to make a equal to 3. And then let's do a switch statement. Switch, and then send the variable in as the argument to switch. So we're going to be testing variable a, and in the case where it is 0, then we're going to echo a equals 0. Put a BR tag at the end and the semicolon after that. Okay, now let's take that same thing. I'm going to paste it here, and let's make our next case that it's 1. Right? See what we're doing here? Let's see the parallel structure. I'm actually going to copy both of those now, save myself some typing. And we're going to make this one 2 and this one 3. I'll change it both here and in the text. So there we go. Now we have our cases. Now remember, I could also have a default case. For now, I'm not going to do the default case. Let's just do the simple one. We're going to test whether it's 0, 1, 2, or 3. If it's not that, if it's 4, 5, or 6, well then none of these will execute. It'll just move on right past this whole statement. So let's save it and let's try it out. Let's go back to Firefox, and instead of logical, we're going to look for switch.php. A equals 3. Perfect. See how that worked? It skipped right past these cases. It tested them. It said nope, 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 yes. This one matches. And so then it executed this statement. All right, let's just try moving a and making a equal to 0. And let's see what happens here. Save it. Let's go back to Firefox and let's reload the page. Whoa, wait a minute. A equals 0, well that's correct, it did match that case, but look what happened after that. It also came back and told us that it was equal to 1, 2, and 3, which it's obviously not. And if we put another value in here, like 2, we go back and reload the page, you'll see that it comes back and it executes the first one and every case that comes after it. It's an important point about the way that switch statements work. They do the statement that matches, and then they continue to match every one that comes below it. Well, that's probably not what we wanted. So if you don't want that behavior, then you've got to provide a break statement. So break, break, and break after each one. Now when we go back, let's make it equal to 0 again. Save it. Go back to Firefox. And there it is, a equals 0. That's the behavior that we would expect, because we told it, okay, you've done your statement, now break out of the switch statement, and that will then drop down here to the curly brace and keep going from there. So this break is super, super important when you're working with switch statements. Drill it into your head and you'll save yourselves a lot of debugging time. Now, as I said, we can have a default case here as well, default, and then echo, and then A is not 0, 1, 2, or 3. And we don't have to have a break here because it's the last one, but I'm going to go ahead just to keep the parallel structure and also just to keep reminding myself that that break is very important to have. So then I'll put it in there, and now let's just try A is equal to 9. Go back to Firefox, and there it is. It's not equal to 0, 1, 2, or 3. So you can see how that works. All right, I'm going to set that back to 2, and let's just drop down here, and I want to show you another example. This example is going to output the Chinese zodiac, the year that it is in the Chinese zodiac. So to do that, we're going to do a little bit of a calculation. We're going to take the year, we're going to use 2013, and I'm going to subtract 4 from it and do the modulo of that using 12. That means that I'm finding the remainder once we divide it by 12. So after we divide by 12 evenly, how many are left over? So that end result is going to be a single value. So even though I've got a calculation in here, it's a single value that comes through in the end, and that's what I'm testing. So whatever that value is, whatever that remainder is, it will check. If it's 0, then we are in the first year of the 12-year cycle. So it is the year of the rat. If it's a 1, well then we know we're in the next year, and the year is the ox, and so on. What I want to show you here though is that white space doesn't matter. Do you see the difference here? Up here we had each one of these on a separate line. Case 1, echo, break. Case 2, and so on. Here I've got them all one after another, very compact, very easy to read. I've even added in some extra spaces here in front of the numbers to keep it all lined up, nice, tight, easy to read. I've still got my colon, I've still got my semicolons to separate the commands, and I've still got break, but the white space doesn't matter. All right, just so we can see that, let's go ahead and bring that up in a browser. I'll put a BR tag here at the end. And it pops up and it says 2013 is the year of the snake. Now there's one last example that I want to show you. I'm going to paste in another example here. Imagine that we have a user type. Let's go ahead and set a user type just so we don't get an error. User type, and the user type is going to be equal to customer, right? It could be customer, it could be student, it could be press, it could be something else. Well, if that user type is student, then we're going to echo back welcome. If it's press, then we're going to say greetings, and if it's customer, then we're going to say hello to them. What I want to show you is, what if you had multiple cases that you wanted to match on something? What if you wanted to have press and customer respond to the same set of statements? I mean, we could say hello and just do it there, but this is a simple example. I mean, imagine if this was in fact 20 lines of code, right? So there's 20 lines of code. Am I going to really repeat that 20 lines of code again? No, I don't really want to do that. Now, this is the thing I want to caution you about. You may be tempted to do something like this and to say case, press, customer with commas between them. That's how you do it in some other languages. It's not how you do it in PHP though. In PHP, if you want them to have the same one, well, guess what? You just put them one after another. Because what happens when press matches? It executes the statements that are here and then all the statements that are below it until it gets to a break. So press customer is going to do the same set of statements because of the way that switch works. You can see now why the switch statement behaves the way it does and why it needs you to put in that break some of the time. It's because there are cases when you're not going to use the break, but when you have multiple values like this. So we could have press, we could have customer, we could have case, when it's admin, right? We can just add more cases, and each one of those is going to do this block that's below it. So let's save it, and let's just try it. Let's go down here. We reload the page, and there it is. Hello is what we get back as the result. That is the statement that goes with the case for customer. So as I said, you're going to use if statements a lot more than you're going to use switch statements. But if you look up here at something like this, where you have the Chinese zodiac, this is the classic case for when you're going to want to use a switch statement. Writing if-else statements for all of this just doesn't give you the same legibility and ease of maintaining the code as the switch statement does. In the previous chapter, we looked at the first type of control structure, logical expressions, which let our code make choices about how to proceed. In this chapter, we're going to be looking at the other main type of control structure, loops. Loops allow us to write code that will execute more than once without having to write out all that code over and over again. The code executes once, and then it loops back to the start to execute again. And each time the code executes, it doesn't necessarily do the exact same thing. The values of variables may be changed each time it goes through the loop, so that logical expressions inside the loop do different things. And of course, a critical feature of any loop is knowing when to stop looping. We're going to take a look at three types of loops. while loops, for loops, and for each loops. We're going to begin with while loops. I think these are the simplest. The syntax is simply while, followed by an expression, that's the argument to it, and then a statement. The statement is the loop. It's the thing that we're going to do over and over again while the expression evaluates to true. Now with a single line statement, this will work, but most times you're going to have a multi-line statement, and I also think it's just a good practice to always use those curly braces. It makes it very clear what's inside the loop and what's not. Now notice how similar the syntax is to our if statement. In fact, if you swapped out the word while for if, it'd be exactly the same. And the expression part works exactly the same way. It's going to be a Boolean expression that's going to evaluate to either true or false. So what happens is it says, while the expression is equal to true, do this block of code. Start at the top and do all of these statements, and when you get to the bottom, come back to the top again and reevaluate the expression. Is it still true? If it is, go through and do all the statements again until you get to the last curly brace. Then back to the top, evaluate that expression again. Once it evaluates to false, well, now we don't do it anymore because we're only doing it while it's true. So now the code jumps back down to the curly brace, it does not execute that final time, and we move on with the rest of our PHP code from there. Let me give you an example. So let's say that we have while the variable count is less than or equal to 10. So as long as that's true, as long as count is less than or equal to 10, we're going to echo the count and then add 1 to it. Then we'll go back to the top and it'll check again. Is count less than or equal to 10? And if it is less than or equal to 10, it will echo the count and then add 1 to the count and go back to the top again. So you can see what's going to happen here. Let's say count started out being 0. Well, the first time through, count is less than or equal to 10, so it executes. This time, count is equal to 1. Still less than or equal to 10, so the loop executes. It keeps on going until finally count is equal to 11. When count is equal to 11, it's no longer less than or equal to 10. It's false. And at that point, it stops executing the loop. Now, two things about the loop are critical. The loop needs to have a condition, an expression, that will allow it to execute. And number two, something about the condition has to change during the course of the loop. If not, you'll end up getting an infinite loop. Let me show you what I mean. Let's say that we didn't have count plus equal 1 in there. If we just took that line out, well, now the first time through, let's say count is equal to 3. 3 is less than or equal to 10, so it will echo 3. Go back to the top of the loop. 3 is less than or equal to 10, so we'll echo 3. And it'll just keep going, and it'll just keep outputting 3s over and over and over again. We have to have some relationship between what's happening inside the loop and the condition that's above it. Something has to eventually change so that now the behavior of the loop will be triggered and we won't just be going infinitely through it. Let's try some examples for ourselves. So to start with, I'm going to open basic.html, just some simple HTML that I've created, and I'll do save as, and we're going to call this while loops.php. I'll call it loops while. So let's just try our very first loop here. And let's do the example that we just had. Let's do count equals 0, and then while, and then our expression. You can have the space here or not. And then while count is less than or equal to 10. And then inside our curly braces, what do we want to do each time? So until count gets to 10, we're going to echo count. And I'm going to go ahead and put a comma after it, concatenate the comma with that period. And then I'm going to do count, and I'm going to use plus plus just to show you. Remember on the slide, I did it using count plus equals 1. Well, count plus plus does the exact same thing. This just increments count. Remember that? So I'll just make a note here. Increment by 1, just so we don't forget. And then let's save it and let's try it out. Let's come back over here to Firefox, and I'm going to go to localhost. And for me, it's going to be Kevin Skogland, and then in my sandbox, and then I just made this one called while loops.php. So there it is. See what I got back? The value started out as 0. Let's just bring these up together so we can see them at the same time. So the first time through, count was 0, so it executes. Count gets output. Now count becomes 1. Goes back to the top of the loop. Still meets the condition. Still the expression evaluates to true. So it outputs it again. Keeps incrementing. Finally, let's look at the top. When we get to 9, 9 is less than or equal to 10. So it outputs. It becomes 10. 10 is less than or equal to 10. So it outputs the 10. And then it becomes 11. It goes back to the top. Now count is equal to 11, which is not less than or equal to 10, so it does not execute this last time. It drops right down to here. And just to make sure that you see this, let's do echo br and echo count colon, and then let's output the value of count here. So after the loop is completely done, let's take a peek at what count is in that last time. See, there it is. So it's equal to 11 after the loop is done. Now, as I said, going through a loop doesn't have to do the same thing each and every time. I mean, obviously the values did change and it went from 0 all the way up to 10, which was nice. We had one little bit of very simple code that actually did something different each time through the loop. But we can do even more than that. Let's do an if statement. Let's say if the count is equal to 5, and then I'll put my curly braces, and I'm just going to go ahead and do else, and I'm going to copy this and paste it in here. All right, so if it's not equal to 5, the else statement is just going to do what it was doing before. But if it's 5, let's have it echo the word 5 with a comma after it. Save it, and let's come back here, and we'll reload. And you'll see that it now pops up and it does something different when it gets to 5. This is a very simple example, but if you think for a second, you can see how it would be applicable. How you would say, all right, if I'm outputting a set of pictures, every 5th picture, I want to put in a different bit of HTML. Maybe you want to do a line break after something, or you want to finish a UL tag and start a new one. Now, I just want to point out what I was talking about with having a relationship between what happens in the loop and making sure that it will exit. If we were to take this count plus plus, imagine that we moved it up here. Imagine that it was inside that else statement. Do you see what would happen? It's going to loop infinitely, because what's going to happen? It's going to get to 5, and then when it gets to 5, it's going to stop incrementing. It's just going to keep looping and looping and looping and looping. So it's important that we make sure that regardless of what conditional statements get executed, that we still end up with a loop that will eventually break out. Now, if you were to do this and you were to create an infinite loop, PHP will eventually time out. The page will say, okay, I've tried this for long enough. This seems to be an infinite loop and I'm going to give up. And that's a configurable option in PHP as to how long it will wait before it gives up. It's not something you typically need to modify. So on your own, I want you to try to make a new example. And in your example, I want you to try and have a different behavior for even numbers and odd numbers, so that as you go through a loop and it counts up, even numbers and odd numbers are handled differently. I will give you a helpful hint though. It might be useful for you to use the modulo operator. That's the percent sign, and that tells you whether a number divides evenly by another number or not by returning the remainder. So it returns the remainder once you do the division. Count modulo 2 tells us how many are left over if we divide count by 2. Give that a shot and make sure that you have an understanding of how while loops work. And we're going to look at for loops next. In this movie, we'll look at for loops. For loops are very similar to while loops. They repeat a section of code until a condition is met. But the syntax used for doing it is very different. Why have both then? Well, probably because for loops are the most classic kind of loop that there is, and they're used in many other programming languages. And some people prefer the more compact syntax of for loops. Let's take a look at that syntax now. A for loop looks very similar at first, except for the expression part. Instead of having one expression in parentheses, we're going to have 3, separated by semicolons. And each one's going to perform a different function. Expression 1 is going to be executed the first time only. It's like an initializing statement before the loop starts. Expression 2 is the test expression that's going to be checked at the start of each loop, just like the expression that we had in the while loop. Expression 3 is going to be executed at the end of every loop, right after the loop finishes, right before it goes back and evaluates expression 2 again. Perhaps a better way to think of it is as initial, test, and each. So there's the initial value, there's the test that it's going to perform each time, and then each time through, the last thing that it's going to do is execute that each statement. Now this syntax will work for a single line statement, but just like we saw with the while loops, I think it's a good practice to always put curly braces around it. And if we have a multi-line statement, those curly braces are required. We have to have it. So I'm going to suggest that it's the best practice for you to always use those curly braces anytime you have a for loop. And then we can tell what's being looped across. It's everything inside those curly braces. All right, so I haven't really fully explained how initial, test, and each work in practice. Let's actually go to some code so that we can try it out and see how they work. So to start with, I'm going to open up basic.html, and I'll just do save as on this, and we're going to call this one for loops.php. We'll call it loops colon 4. All right, now to begin with, I'm actually going to paste in a while loop. While loop example. And I want you to see this while loop because the way that it relates to the for loop I think will help for loops make a lot more sense to you. So let's write our for loop now right below it, and let's try to accomplish the exact same thing that the while loop does. So we're going to have our PHP tags, and then let's start with for, and then we have our initializing statement, right? That's the first argument. The thing that we're going to do at the beginning is initialize. So we did some initialization up here. Look at this. Count equals 0. We initialized the value count before we did the while. Well, that's exactly what we want to do here. That's our initialization. Here it was on a separate line. Here it's inside the arguments to the loop. Now, right after that, we need a semicolon, so we have a second statement after that. And the next statement is going to be the expression of what we do each time through. And I told you that was exactly like the while loop. So we're just going to copy that. We're going to put that in there. And then the last one, remember, is something that happens at the end of every loop right before it goes back again. Well, let's look at our while loop. What are we doing each and every time? We're incrementing. And that's probably the most common thing that happens in this third expression. You could also decrement. It could be count minus minus, or it could do something much more complicated. It could divide by 2 or multiply by 4. All sorts of things could go there. But typically the most common one is just to simply increment. So now that we have that, we just need to put our curly braces, and then what are we actually going to loop? What's the business that we want to do each time we go through this loop? Well, there it is right there. We're just going to take count and then output it. So some people like this syntax better. We're doing all the initialization, we're doing the incrementing, we're doing the testing all in one line. It's all kind of get that business out of the way right there at the start, and then what's inside our loop is a little more isolated. It has nothing to do with the business of looping. It really is just the thing that we want it to do each time through. So let's try it just to make sure that this works. Let's give ourselves a BR tag here, just so we can separate that out from the one before it. Let's go with Firefox, and instead of while loops, we're now going to open up for loops. And there we go. See, it did the exact same thing right underneath it. Now, just like we had with while loops, we can do all the same things. You want to watch out for infinite loops. And you can have if statements inside here that do conditional operations. So as another example, let's look at the loop that I gave you as an assignment at the end of the while loop section, something to do on your own. Let's try those results here. So we'll do BR tag, and then I'm going to paste in a for loop. It's going to start out with count equals to 1. Count is, while it's less than 20, it's going to keep executing, and each time it's going to increment count. Now, just to see the difference, let's just try it in reverse. Let's say count is equal to 20 to start with, and as long as count is greater than 0, then we're going to keep going. So we're going to count down, and if I'm going to count down, then I need to do minus minus here at the end. You also could do minus equals 1 if you wanted. That does the exact same thing. Now here's the heart of my loop. If count modulo 2 is equal to 0, that means if I take count and divide it by 2, if there is no remainder, right? If it divides evenly, then it'll be equal to 0. Nothing left over, then I'll know that it's an even number. Otherwise, it's an odd number. All right, so let's just try that out. Let's go over here to Firefox. Let's reload. There it goes. 20 is even, 19 is odd, all the way down until we get to 1 is odd. So hopefully you see how that works, and you see the relationship between a while loop and a for loop. How they're basically doing the exact same thing. It's just a different syntax and a different way to write it. Use whichever one feels most comfortable to you. They both accomplish exactly the same thing. It's just a matter of personal style and taste. For each loops are a little different from the previous two types of loops. For each loops are going to take an array and then loop through each item of the array until it gets to the end. If you think back, while loops and for loops know whether to quit or to keep looping by testing if a condition has been met. For each loops, on the other hand, are going to know whether to quit by whether there are items left in the array to loop over. The end of the array is what ends the looping. It's really just two approaches to looping. Let's use a real-world scenario for a second. Imagine that I have a classroom with 20 kids in it, and I have to put name tags on all of them. Now I could just go around the room, and I could put a name tag on each kid and keep track of the numbers as I went. And knowing that there are 20 kids, when I had gotten to the number 20, I'd know I was done. Or, since I know that I have a finite set, I could just line them all up, start at the beginning, and move down the line And when I got to the end of the line, I would know I was done. I wouldn't have to keep track of the count as I was going. I mean, I could count. I could certainly know that I was on the fourth kid, but I wouldn't have to. I could just start at the first kid, go to the second kid, and then the third kid until I got to the end of the line. That's how a for each loop works. The syntax is also a little bit different. We have for each, and that's for each all run together, no spaces, no underscore, anything like that, just for each. And then in parentheses, we have a special statement. The first thing we're going to provide is the array that we're looping through. So that's what I've got there with the variable array. It doesn't have to be called array. It's a placeholder to show you that that's where the array goes. And then we've got this special keyword as. That's part of the for each statement. It's a special keyword that it uses. And then we have another variable after that called value. Now value also can be named something else. What it's doing though is that each time it goes through the loop, each item in the array is going to be assigned to this variable value. Value is just now being defined here. Array is a value that existed before the for each statement. Value doesn't. Value is something that we're creating right now for use only inside the loop. And then each time through the loop, we have access to that variable, and that variable is a reference to the item in the array that we're currently working with. If that seems at all fuzzy, don't worry, it'll make a lot more sense when we see an actual concrete example. Now, just like the other loops though, I think it's a good practice for us to put curly braces around our loop so it's very clear where the loop starts and stops. With a single line statement, it's not necessary, but a multi-line statement, it definitely is. Now, I want you to notice something else about this for each statement. It's the same thing that I told you at the beginning. Notice that there is no condition here. There's no condition and there's no mechanism for incrementing, right? Those are two things that both of the while and for loops used. They had a condition that had to be met to know when it should exit the loop, and it incremented. This one doesn't. Why not? Well, because the condition for exiting is when it gets to the end of the array. And it doesn't need to increment because it knows when it gets to the bottom of the loop, it knows what it should do. It should go to the next item in the array. So both of those are missing here. All we're doing is saying for each one, assign it to this variable and then do the loop. Let's try an example. An example will make this clear. So let's open up basic.html again and let's do save as. And this time we're going to save it as foreachloops.php. And I'll call it loops for each, no spaces. So I'm just going to paste in our first example here. I've got an array filled with numbers and I'm assigning it to the variable ages. So now here I have my for each loop and it's going to take that array that ages points to, and as age, so each one of these values is going to be assigned to the variable age temporarily. Notice the difference here, the singular and the plural, right? Age and ages. Ages was defined before. Age is just now being introduced here. Now each time through the loop, I have access to the age right here to use, right? Let's bring that up and try it in a browser. Go to Firefox and instead of for loops, I'm going to bring up for each loops. See how that works? Age 4, 8, 15, and so on. Every time it goes through the loop, the next item is assigned to age so that I can work with it. And it just moves down this list. If there's 6 items in the array, well then it's going to loop 6 times. This is very useful when you want to traverse an array. Imagine that you have a list of a user's last 15 orders that you want to output to them. Well, that's an array. The 15 orders are an array. You could use a while loop or a for loop as you iterate through those, but the for each loop really works better because the for each loop says, all right, start at the beginning of these orders and let's start going through them. And when we get to the end, we're done. Loop through it however many there are. If there's 15, show all 15. If there's 20, let's show 20. And it's especially nice because then each time through the array, the customer's order would get assigned to a variable called order that would have everything we needed to then output, the same way that we're working with age now. Now you may be asking, well, this works for regular arrays, but what about associative arrays? Remember we talked about associative arrays before, where they have a key and a value? We just have to modify our syntax slightly to make associative arrays work with for each. The overall structure is the same, but we're going to have array as, and then we're going to have 2 variables that we're going to assign. One for the key and one for the value. Now they don't have to be called key and value, they can be called anything you want, but the important part is that we have 2 variables. And between them, we have the equals greater than sign, just like we use in the associative array to separate our keys and values. Let's try an example using associative arrays. So again, I'm going to paste in a block of code. Remember, you can pause the movie if you need to copy this down. What I've got here is a person, And that person has an array of data, and it's labeled. First name, Kevin. Last name, Skoglund. Address, city, state, zip, right? All that information. And then for each item in person as, I'm calling it the attribute and the data. Not key and value. These are the key and the value. That's the technical name for it. This is the key, this is the value. But I'm going to be assigning them to the variables attribute and data. Now in the next line here, I've got a couple of string functions at work. We talked about some of these before. We have UC words and string replace. What I'm doing is cleaning up this attribute, which uses underscores in it and lowercase to make it look nicer. Take away the underscores and uppercase the first words. I'm calling that attribute nice, and then I'm outputting attribute nice and the data. Let's take a look. I'll save it, come back over to Firefox, reload it, and there we go. First name Kevin, last name Skoglund, address 123 Main Street, and so on. See how that works? I specifically wanted to show you this example by using the UC words and string replace because this is the kind of thing you'll get back from your database as the name of a database field. And we would want to clean that up before we showed it to the end user. We don't want to show them all the underscores and everything. We want to show them something that's a little bit nicer. So I'm going to give you one more associative array example before we move on. Here I've got just another array, and I've got brand new computer, 1 month of lynda.com, and learning PHP are the keys. The values are 2000, 25, and null. So I've assigned that to prices. For each item in prices, I'm going to assign those to item, because each of these are items, and each of these are prices. And each of these is going to be assigned to price, because that's what they are, they're prices. And then as I iterate through each of these, I'm also going to have a conditional statement here that's going to check to see whether or not price is an integer, which will be true for the first two, but not for the last one. And so let's go ahead and just load that up over here. That's a little bit of a joke. But you can see brand new computer, $2,000, 1 month of lynda.com, $25, learning PHP, priceless. Hopefully you now understand how for each loops work. Whenever you're working with an array, you should first think about using for each loops before you go to one of the other types, because for each loops are tailor-made for working with arrays. So if you have an array, chances are for each loop is what you want. We've now taken a look at 3 types of loops: while loops, for loops, and for each loops. In the next 2 movies, we're going to learn how to use the functions continue and break to get more utility and flexibility from these loops. We'll start with continue. Continue is used inside a loop to skip the rest of the current iteration and to go immediately to the condition evaluation that starts the next iteration. It may sound silly, but for me, continue evokes the image of a Hollywood casting director shouting, "Next!" in the middle of an audition. It's like saying, "We've seen enough, thanks, let's skip ahead to the next one." To give you an example, let's imagine that we have a database of college students, and our code is going to loop through them and send them all an email. But if the student is already signed up for a biology course this semester, then we aren't going to send them the email. So we start the loop, we check to see if the student has signed up for biology, and if so, then we know that we don't need to do any further processing at all. We can just skip to the next student record. That's what continue allows us to do, and it makes our code more efficient. Let's see an example. So let's open up basic.html, and let's do save as, and we're going to call this continue.php. I'll change this to continue, and I'm going to start with just a basic for loop. So here's the same for loop we were looking at before, just counting the numbers 0 to 10 and echoing them out. We saw an example earlier where we said if the count is equal to 5, then do some different behavior, right? We outputted something different. Instead, this time, I'm going to have it just do continue. That's our continue function. So continue with a semicolon after it is the only thing. Let's save it and let's bring it up in our browser and look at what it looks like. So here I'm in Firefox, and instead of for each loops, let's go to continue. There it is. I think this makes it really clear what continue does. We get to the number 4, and there is no number 5. It picks up again with 6. Let's go back and look at the code. When it's 4, well, it doesn't meet this condition here of the if statement, so it outputs 4. Then 4 gets incremented to 5. Count is still less than or equal to 10. Now count is equal to 5, so we continue. Continue tells it to immediately loop. That increments the counter to 6. It checks and sees that 6 is less than or equal to 10. This time it echoes the 6. One way that you can think about it is that there's an implicit continue at the end of every loop. Now we don't need to actually write it out there because it's built into the looping structure. But what we're doing in this case is we're telling it to loop earlier. Instead of having to wait till we get to the continue that's at the end of the loop to tell it to loop again, we have this continue here telling it to do it when we want. Now, if you're doing something so simple as this, I just want to remind you that white space doesn't matter. Something like this would do just as well. I'm going to change this to be our modulo operator with %2 equals to 0. Let's just bring that up and try it. And that basically says that we're going to print out the odd numbers, right? Whenever the remainder of dividing count by 2 is equal to 0, then we're going to continue. We're going to skip over it and we don't do anything. We don't do any further processing and it never gets to this echo statement. Now you may be tempted to think that we could use an if statement instead, that we could do something like this. If the remainder of dividing by 2 is not equal to 0, then echo it out. Otherwise, don't, right? But that kind of misses the whole point of why continue is useful. With a simple one-line statement like this, they are practically the same, but imagine if our if statement had 100 lines of code in it. Then if I'm reading the code, I would need to scroll down 100 lines to find the end of the if statement, and then check to see if there's any other code that would be executed before the loop finishes. With continue, we don't have to do that. We know what happens. As soon as the code gets to continue, the loop starts over again. It's explicit and it's definitive. It says simply we're done and we're moving on. It makes our code clearer, both easier to read and easier to understand. Let's try another example using a while loop. So here I've got a simple while loop. You can see that it's basically the same thing that I had with my for loop. I've got my count being initialized. Here's my condition when count is less than or equal to 10. And I'm incrementing here, count plus plus. I'm echoing the count just like I was before, and I've gone back to the other version with count is equal to 5, continue. But there's a big difference between this one and the one before. And that's why I've put what's wrong with this up here, because this has a problem. Do you see what it is? You may want to pause the movie and take a second to look at it and see if you can figure it out. Walk through the loops with me step by step. Let's imagine that count is equal to 4. That's less than or equal to 10. It's not equal to 5, so we output 4. Then 4 gets incremented. It becomes 5. We go back to the top of the loop. 5 is less than or equal to 10. Now, count is equal to 5, so we continue. That goes back to the top of the loop, and it evaluates count is less than or equal to 10. Well, what is count now? It's 5 still. We didn't increment it. So it comes down here, count is equal to 5, we get continue, we go back, we check the condition, and we're stuck in an infinite loop. We never get to this increment that's down here. With for loops, that doesn't happen because this incrementation is built into the loop. It always does this last step. With for each loops, it also isn't a problem because those always move to the next element in the array. But with while loops, it's not necessarily true. This incrementation is optional. It's up to us to provide it. So what we really need to do is fix it by making sure that we still increment before we continue. So when count is equal to 5, make it 6, and then go to the next one. This is an important tip when working with while loops and continues. It's a gotcha that can sneak up on you if you're not watching for it. Okay, let's make sure that we fix that. We're not going to bring it up in the browser right now, but I want to show you one last example because there's one more thing you need to know about continue, and that is how to work with continue when you have a loop inside a loop. So here I have one loop. I've got 4, and I'm using I for my counter now. By the way, that's very common when we have loops, is just to use a simple single letter variable. So I is counting from 0 to 5. Then I've got my modulo operator here, so that when we get to an even number, it's going to use continue. Then I've got another loop inside a loop. This one's going to use k, and k is going to count from 0 to 5. And it's going to just echo out I with a hyphen, and then k and a BR tag. Let's take a look and just see what that looks like on its own before we try doing more. Let's come back over to the browser. Let's reload. You do want to make sure that you fix this problem up here before we come back and try it. Otherwise, you'll have an infinite loop. So you can see that the results I got are 1-0, 1-1, 1-2, 1-3, 1-4, 1-5, and then it jumps to 3-0, and then eventually 5-0. Okay, so there's my series that I've generated. Now what I want to do now is I want to add another line here right before the echo, and I'm going to do another continue. Let's say if k, I'm talking about k here, is equal to 3, not the modulo, but k is actually equal to 3, then let's continue. Okay, so let's take a look at what that does. Come back over and reload it, and notice that now 1-3 is missing, 3-3 is missing, and 5-3 is missing. And that makes sense. That's what we would expect to happen. Continue continues this loop. It comes back to the top of this loop, therefore just skipping 3 essentially each time on the second loop. But what if we wanted this continue not to apply to the innermost loop, but to the outermost loop? What if we were essentially saying, look, we've got a whole bunch of loops going and processes, we're looking for something, and once we find it, we want to tell the parent that it should continue. We don't need to keep doing any more of the loops here as well. Well, the way that we do that is we can provide an argument to continue. Put parentheses and then an integer inside of it. By default, continue has an integer of 1 as an argument. But if we provide another number like 2, then that tells it that it should continue not just one loop, but 2 loops back. So don't just look for 1, go all the way back to this looping structure and continue that one. So this is different. This one is the same as that one. I'll leave it in there just so that you see the difference. And then 2 is telling it to skip that one. Let's save it, go back and reload our page and see what happens now. Now when it gets to 1-3, it doesn't do 1-4 and 1-5. It goes ahead and jumps to the next one, to the next iteration using 3. Go back and forth between those two if you need a little more time to understand the difference. Now that we understand how continue works, in the next movie, we're going to take a look at break. In this movie, we're going to learn to use break with our loops. We've seen break already. Remember, it was an important part of working with switch statements. We used break to stop execution of any other cases and then to exit the switch function. We'll use it in a similar way with loops. Break will end execution of the loop. Not just the current iteration, but all iterations. You can think of it as breaking out of the loop. In the last movie, for the continue function, I suggested the image of a Hollywood casting director saying next in the middle of an audition that was in progress. Let's continue that metaphor here for a second. Break would be as if the casting director watched a few auditions and then said, this is the one. You've got the job. The rest of the auditions are canceled. I don't need to see any more. Break stops the whole process. And it's very useful when we've found what we're looking for or when we've reached a definitive answer to a question. We can stop looking, stop looping, and move on. Let's create an example. We'll start by taking basic.html and using save as, and we'll save it as break.php. Up here we'll write break. And I'm just going to put in a simple loop, and I've got continue in there. This is the exact same loop that we had in the last movie. First, let's just bring up this version and look at it in a browser and remind ourselves what it does. I'll just save it, go to Firefox, and instead of continue now, I'm looking at break.php. So there it is. Notice that the 5 is missing because continue told it to skip over the 5. Instead of continue though, now let's tell it to break. So if it count is equal to 5, it will break. Let's come back here and notice now it ended execution completely. It stopped not just this loop and stopped from doing the echo statement, it ended this entire loop. It broke out of it. So once we get here and count is equal to 5, it executes break, and the very next thing it does is it drops down here to the last curly brace and continues processing our PHP code from there. It never goes back and does any of these tests or increments or anything else. It just immediately exits our loop. Break will make your code a lot more efficient. Let's imagine for a moment that you have 20,000 customer records, and we're looking for one record that matches a certain criteria. If we find the one that we want when we get to the 100th loop, do we really need to keep looping for 19,900 more times? No. It's much more efficient to just break out of the loop and to say, I found it, we can stop looping and move on from here. Now, since you understand continue, I don't think we need to spend a lot more time with break. I think you get the idea behind it, but I do just want to show you that we also should take a look at what happens when you have a loop inside a loop using break. Remember, we did this with continue, and we had this example where we had continue and we provided the argument of 1, or continue 2, which told it to continue out of 2 loops. Well, let's look at this with break. Let's change this second one to be break. All right, actually, let's remind ourselves first of all what this does. We'll just comment out this line, and let's go back and reload the page. Okay, so that's what it looks like. That's what it does on its own. Now let's uncomment those lines, and then when it gets to k equal to 3, it's going to break. So there we go. Notice that the 1-3, it did a break, and at 3-3 it did a break. It didn't do the items that were after that, but it did keep doing the first item. It did keep iterating and advancing I. Just like continue, if we provide an argument to it and say that we want to break out of 2 loops, it will break out of both of them. We have control over which ones we break out of by using an integer as an argument to break. Let's just try that so you see the difference. So here we basically said, all right, we're drilling down through one loop, we're using another loop, we finally found the item, k equals to 3. That's it. So now just break out of the looping structure completely. We don't need to keep doing anything else. You can go back and forth and change this number between 2 and 1 to see the difference between what it does. Now that we understand the 3 types of loops and how to use continue and break with them, we'll be able to write very efficient looping structures. Before we move on, I want us to look at one more thing, which is how array pointers work, and we'll do that in the next movie. Before we leave the topic of loops behind, I want to talk about array pointers and show you how they work. It may seem like a technical detail, but it will become important later when we start working with databases. PHP maintains a pointer that points to one of the items in an array. That item is referred to as the current item. By default, that's always the first item in the array. When we start looping through arrays using something like Foreach, PHP moves the pointer down the array as it assigns each value to the loop's variable. Moving the pointer to the next item is how PHP keeps track of which item you're working with now and what the next item is that it should give you after that. But loops are not the only way to move pointers around. Let's take a look. Let's create ourselves a little workspace by using basic.html, and we'll use save as, and we're going to create pointers.php. To begin with, let's just give ourselves a little area here, PHP, and we'll put in our array of ages. I'll also change the title to be pointers. All right, so this is the array that we were working with before. So the pointer, by default, the current item that's being pointed at in this array is the first item, 4. As we do a loop through there, the pointer moves. So the first time it's pointing at 4, the second time through the loop, it's now pointing at 8, and then it's pointing at 15, and so on. It moves all the way down, and when it gets to the last one, then it moves one more and says, oops, there's no more items, I must be done. And so the loop ends. We can take a look at this current pointer value by using the current function. So here it is, just current, and then we pass in the array. That'll tell us what the current value that it's pointing to is. Let's try that. Let's save it. Let's go back to Firefox, and instead of break, let's open up pointers.php. So there it is. It's pointing to the item 4. I've got the 1 in front of it just so that we can tell the difference between each of these tests that we run. So here's 4. Now we can tell the pointer to move to the next item manually by using the next function. So here's it is. It's just simply next ages. We're just saying, hey, advance the pointer for ages to point to the next item. And then we'll once again echo back what the current item it's pointing to is. This time I've got a 2 in front of it so we can tell the difference. I'll save that. Let's go here. And there it is. It's pointing at 8. See how that works? Let's go back and let's just do a couple more here. Let's tell it to go 2 more times, and then we'll do a third one. And we'll ask it what it is for the third time. All right, it went 2 this time, so we're at 16. So you skipped over the 15, and now we're pointing at 16. We can also have it go backwards by using prev, short for previous, P-R-E-V, and that's going to move it backwards. So tell ages to go backwards 1, and then we'll use number 4 to see what the value's at now. And there it is. It's at 15. It went backwards 1. We also have 2 more that we'll look at together, which are reset. So reset will move the pointer back to the first element, and end will tell it to shoot all the way to the end, to the last element. I've numbered those 5 and 6. Let's take a look at that real quick. So there we are, the first element and the last element. And now, just so that we can see what happens when we're at the end, let's go ahead and do next one more time. So here it is. It's at the end. We're going to call next after the last element, and that'll be number 7. Let's see what that gives us back. We'll do return. We get back nothing. Right? So that's how it knows that it's done. When it retrieves the last item, if the last item is null, then it knows that it's done. Okay, so how is this useful? Let's take a look at a while loop example that will illustrate how it works in practice, and which is going to set the stage for working with database records. Switch back over here, and let's just put a BR tag, and then we'll put in my while example. So it's a while loop that moves the array pointer. This is very similar to what Foreach does. Notice that in the condition of our while loop, right here, this expression, that we're doing an assignment, not a comparison. That is a single equal sign, not a double equals. What we're doing is we're assigning a value from current to age, and we're also testing then to see if that assignment was successful. If it returned a value, then the expression is going to evaluate to true. But if it returned null, in other words, we got to the end of it, then this expression will evaluate to a Boolean false. Null will be considered false. And so at that point, it will exit. So what we're essentially saying is, get the item that the array pointer points to, assign it to age, and if that is an item, if you successfully got one, then execute the loop. If you did not successfully get an item, well then exit the loop. We're all done. And then of course we do have to increment inside the array using next. That'll move the pointer to the next item so that now current will fetch something different the next time through the loop. So as I said, this is how Foreach works. So why not just use Foreach then? Well, I want you to see this technique because when we start working with databases, we're going to use something very similar. We'll retrieve many rows of data from a database table as an array and then move through each row, advancing the pointer as we go. But we can't use Foreach for this because the database pointers are not exactly the same as the array pointers. They're similar, but not the same. And the database pointers are going to be moved by the database driver each time that we request a row. Each time that we do this assignment here, it's going to increment the pointer as soon as it finishes making that assignment. Foreach and next won't be able to move those database pointers. They're going to work only on PHP arrays, not on these database arrays that we'll be working with later. So let's just try out this code real quick. Let's save it, and we'll go back to Firefox. Let's try and reload the page. Notice that nothing happened. Well, why is that? Well, it's because current is still pointing at null. Remember? Current here was null, so what is it here? It's still null. Nothing has changed. We need to reset the pointer back to the beginning for ages. And now, when we come back here, you'll see that it zips back to the beginning and it starts going through with each one all the way through till it gets to 42, and then the last one is null, so the loop ends. So I hope you understand how pointers work, and this gives you some insight into how Foreach works and also how you can manipulate those pointers yourself. But more importantly, I want to make sure that you're familiar with this syntax using the while loop, because that's what we're going to be using when we start working with databases. A function is code that performs a specific task, which has been packaged up into a single unit that can then be called upon whenever that task is needed. An example of a function that we've already seen and used would be inArray. Anytime that we want PHP to check whether an element is in an array, we can call the inArray function. We provide the function data to work with in the form of arguments, and the function returns output to us at the end. This is a common feature of functions, providing them input and getting back output. Up until now, we've been looking at the built-in functions that PHP provides, but we aren't limited to just these functions. We can also define our own. In this chapter, we'll learn how to craft and use custom functions, and we'll start by learning the syntax that's used to define them. You define a function by first saying function, and then a space, and then the name that you want to give this function. It's very much like the variable names that we assign, and the rules are very similar. We can have letters, numbers, underscores, and dashes. You can't have any spaces though, and it must start with either a letter or an underscore. Unlike variable names though, function names are case insensitive. So with a variable, if we had capital var and lowercase var, those were two different variable names. But if we have a capital function and a lowercase function, they're going to be the exact same thing. However, it's really bad programming practice to start switching case around. So whatever you define them as, that's how you're going to want to always call them as well. Pick one style and stick with it. For me, I like the all lowercase with underscores style, and that's what I'll be using. After we have the name, then we have parentheses with our argument list. These are the arguments that the function is going to accept. In this example, I've just got arg1 and arg2 separated by a comma between them. Both of these are going to be variable names, so they're going to have the $sign in front of them. We could have more than two. You just put a comma and then have arg3, arg4, and so on. You'll probably want to use a better name for yours that will actually describe what you're expecting to get in. So if you're looking for an array, the name of it might be array. And then we've got our curly braces after that, and inside that is the meat of the function. It's all of the code that we're wrapping up inside this function. This is the code that we want to reuse and be able to call from a lot of different places. This code tells PHP, take this block of code inside the curly braces and keep it around. File it under the name, and when I call for that name, take the input that I send, run the code, and give me back the output. Let's try an example. So to start with, I'll open up basic.html, and I'll do save as on this, and we're going to call this functions defining.php. And I'll give the title functions : defining. All right, so let's write our first function. We need our PHP tags. To write our first function, we're first going to use the keyword function, followed by the name, and I'm going to call this one say_hello, and then the arguments. Now there's not going to be any arguments to this one, but I'm still going to put the empty parentheses there so that it's clear that that's where the arguments would go. And then curly braces, and then whatever code we want to package up, whatever we want to happen when we call this function. And I'm just going to have it echo the classic hello world, exclamation point, put a BR tag, and a semicolon at the end. Okay, so there I have. I've defined my first function. This is not something that pre-existed. This is something that I'm defining. Let's go to Firefox and take a look. So I'll open up Firefox, and it's going to be localhost. And then for me, I'm going to use Kevin Skogland, sandbox, and then functions underscore defining.php. Okay, I didn't get anything back. Now I am seeing the right page, and you can tell that because it says up here at the top, functions defining, right? So that is the page that I'm on. And we can actually go to our web developer tools, and we can view the page source, and we can see that we got something, but there's nothing in there. Nothing gets output when you define your function. We have to then call the function. So what we're saying to PHP is, take this code and store it for later because I may call on it. But we haven't done anything. We haven't called it. It just simply set it aside and assigned it the same way as if we had assigned a variable, a value. We just assigned a block of code to the say hello function. Now in order to call it, we need to say hello. Let's try it now. Let's save that. Let's go back over here. And sure enough, hello world pops up. Now the parentheses here are not optional. If we are calling a function, we want to make it clear that it is a function. If we take it away, then PHP sees this as something different. Go over here and just reload it so you can see the difference. You can see that we get a notice saying that we are using an undefined constant to say hello. Now, that's not what we wanted at all. We were trying to call our function. So when we call our functions, even if there's no arguments, we're going to use just two parentheses afterwards. So the correct way to say this is that we are calling the function. We're calling the say hello function. All right, now let's try this with our first argument. Let's come down here and let's define another function, but this one is going to be say hello to underscore to, and then we'll put an argument in here, and that will just be word. All right, so that's our first argument is word, and then we have the ability to use that argument inside our function. So for example, I can now have $word, right? See how that works? So this is now accessible to me inside there. Just like my loop local variables are accessible inside a loop, well here the function arguments are accessible inside the function. So let's try that out now. We're going to call it with say hello underscore to, and we need to provide a word. So let's just start with world, right? Let's go back, save it, reload the page, and there you go. See, we get the second time, say hello world. Now why use arguments? Well, because we have flexibility then. That's the nice thing about arguments is we can reuse that code, but we can have it do something slightly different based on the input that we pass in. So say hello to everyone now returns hello everyone. Now this is a super simple example, but regardless of what task we're trying to perform, what we want is to take input and based on that input, get back different output. We don't want the same output every single time. Now of course, we can't call a function that doesn't exist. Hello loudly. Let's try that. Come back over here, reload it. You'll see that you get fatal call to undefined function, say hello loudly. It's undefined. We didn't define it like we did these other ones. Now, it may surprise you to know though, that we can actually take this and let's do say hello loudly, and we'll just make this hello world in all caps. Let's go back and try this now. Reload it, and it worked. But notice, I defined it after I called it. Right? It doesn't do it sequentially. In PHP 3, it did have to proceed calling it, but PHP 4 and 5 actually pre-processed the page to find all of the functions first. Now, it's still a good programming practice to put them before calling them because someone looking at your code is more likely to be reading from the top down and to be surprised that they haven't seen it defined. So don't get in the habit of defining it later. But it's not going to cause you problems if you do accidentally put a function after calling it. It's still going to be available to you. Now, once we've defined a function though, we can't redefine it. Let me just do another say hello loudly here, and I'll just change this to we can't redefine a function. And let's just come over here and try that out. And you'll see fatal error, cannot redeclare say hello loudly, previously declared at this spot. It tells us where it's located. So we can't do that. So I'm just going to comment that out so that that won't cause our page to break anymore. Now, you can define functions inside other functions, inside if statements, inside loops, but this is really advanced usage and it can lead to many problems and unexpected results for beginners. So for now, be sure that you're always defining your functions at the, quote, root of your PHP page, not inside any other PHP structure. Now that we understand the fundamentals of defining functions, let's explore how to use them a little further in the next movie. In the last movie, we learned how to define and to call functions. In this movie, we'll gain a better understanding of how we go about working with arguments to our functions. Let's create ourselves a new file for this. I'm going to open up basic.html and we'll do save as, and this one is going to be called functions_arguments.php. And then let's change this up here to be functions arguments, and let's start out with just the basic say hello to function that we used in the last movie, which has one argument, word, right? So we've already worked with arguments before. We've seen one. Here it is. We've defined a variable word that we know we're going to pass a value into. We pass in the string everyone to that, and that everyone gets assigned to word, and that's what's available for use inside the function then. We already know how that works. I just want to show you a slight revision of that. Let's say that we have another variable here called John Doe, and instead of passing in everyone, well, we're going to pass in the variable name. So name equals John Doe, say hello to name, and that gets then passed into the function, and it should say hello to John Doe. Let's try it. Let's go back to Firefox, and instead of functions defining, it's going to be functions arguments. Hello John Doe. Works exactly as we expected. Now we're passing in a variable, but a variable is just a reference to a string, so it shouldn't be a surprise to us that this works. But I want you to notice that even though the variable is name outside the function assigns that to the variable word, and word is what it uses inside the function. These two don't have to match. So don't worry about that. Whatever it has out here, that's the one that exists outside the function. The function has its own sort of self-contained world of variables. We'll talk more about that a little later on. For now, I just want you to see that the two don't have to have a relationship. Now let's try some functions with more than one argument. If you remember back when we used the built-in PHP function string replace, we had 3 arguments to it. The first was the string quick, the second was super fast, and the third was a string that we had assigned to the variable third. Now of course this is already predefined for us by PHP, but if we were to define our own, it would look something like this. Function, string replace, and then the 3 arguments, right, that go with it. And those might be find, replace, and the target. So we're finding one string, we're going to replace it with another string, and we're going to do that inside the target string. That's the third one. Now, it doesn't matter what this function does, what the statements are inside of it. What I want you to see here is the relationship between those 3 when we're defining the function and the 3 when we're calling the function. Notice that there are always 3 of them that fit each of those spots, and they're always in the same order. That matters when we're having multiple arguments. The order matters and the number matters. So let's try our own. Let's drop down here. I'll create new PHP tags, and let's put in function. We'll call this one better hello. And for now, I'll just flesh it out like that. All right, so let's have 3 arguments here to this. This one will be greeting, and then we're going to pass in the target, and then the punctuation, which I'll just abbreviate PUNCT. And then I can use those 3 values inside my function as I go about the work of my function. So I'm going to say echo back the greeting, and then let's concatenate that with the space, and then we'll put the target, that's the person that we're greeting, and then followed by concatenating that with the punctuation. And last of all, we'll put BR tag at the end just to make it look nice, and a semicolon for the whole thing. See how that works? So we have 3 different ones that we're working with. Now these don't have to be in this order. We could jumble these around. The important thing though is that whatever order that we define them in, that's the order that we call them in. We must always call it with the same number of arguments and in the same order. So better hello, and then we can now say that our greeting is going to be hello. We'll say hello to the person that is stored in the variable name, and last of all we're going to have our exclamation point as our punctuation. All right, so let's just try this out, make sure that our 3 arguments are all working. And there we go, we get hello John Doe again. Now, of course, it's flexible. We could just as easily change this one to greetings and put 3 exclamation points after it, right? Greetings, John Doe, with 3 exclamation points is what comes back. Now, as I said, we have to have the same number of items, but let's try putting in null here for that last item. So we're providing a value, but that value is null. Let's come back over and reload the page, and you'll see what it did. It converted null into a string, which is nothing. We could have also just as easily provided an empty string and it would have done the same thing. The important thing is that we have something there in that place, that if we are asking for 3 things and when we define it, that we are sending 3 things whenever we call it. There has to be agreement there. A little later, we'll talk about how we can set default values for these arguments so we don't always have to send the exact same number. But before we do that, I want us to first talk about return values from a function. We'll do that in the next movie. All of our functions so far have been using echo to send output to the user's screen. But more often than not, we don't want that behavior. Usually we'd like to get a result back from the function and then decide what to do with that result ourselves. We might end up deciding to echo it to the screen, but we might instead take that value and continue to use it to do more processing. If it outputs from inside the function, then we lose that flexibility. It's better to get back a value. And for that, we need to understand how to return values from a function. Let's open up basic.html, and we're going to do save as on this, and we're going to call this one functions underscore return values.php. Functions return values. So let's just write a simple function here. I've got an add function. It takes 2 arguments, value 1 and value 2. It adds them together and assigns them to sum. So let's just load this up in Firefox to begin with. Let's bring this up, and instead of functions arguments, instead now we're going to be loading up return values with no space in between. All right, I get nothing back. You can see it did load the page, but all I did was define the function. I haven't actually called it yet. So let's try calling it now. Add 3, 4. All right, let's save that. Let's go back and reload the page. Still didn't get anything back. Why not? Well, it's because we're not echoing anything from inside the function like we did before. We could put an echo here, echo $sum, and that would now output a value, but that's not as flexible. That doesn't return the addition to us, so it would work with it. The only option it gives us, the only way to get a value out, is to print it to the browser. Now we could try printing this value from outside the function. Let's try that. Let's do, after we add them together, let's echo that value. And it comes up and says, nope, undefined variable, because sum is a variable that's only inside the function. It doesn't exist outside the function. So we can't use this as a way to get values out of there. Instead, what we want to do is we want to return a value from the function. So we would have return, and then what we want it to return, sum. So now it'll return sum to us, and then we need to catch that result here by saying the result is equal to add 3 and 4. Now we get back the result and we have the ability to echo that result to the screen. Let's take a look at that. And now we get the value of 7. Now we don't have to echo this to the screen. We could instead do more operations with it, right? We could have, now the result is to take 5 and add that to result, what result was previously. We can actually name these results 1 and 2 if that makes it a little clearer, instead of overwriting the other one. So result 2 now is equal to result 1 plus 5. Come back here and we get 12, right? Much more flexible. We have the ability to output it or the ability to keep working with it. The best practice when you have functions is to always have a return value. Explicitly say, what does this function return? Maybe what it returns is null. Maybe what it returns is the original input again. Maybe your input was an array, and so the output is to output that same array again. But you always want to return something from your functions. The PHP functions have return values. All of those are listed on the php.net website. There's usually a section that says the return values. It tells you what the inputs are, and it tells you what the outputs are. So you can look those up. Now the return also exits the function immediately. It's similar to how break works, where break just got us out of a loop immediately or out of a switch statement immediately. Well, return works the same way for functions. It says, all right, just stop whatever you're doing. Let's exit the function and return this value. This is the thing that needs to be passed out of the function. No more processing required. And even when we put it inside loops or switch statements that are in the function, it will immediately exit from those as well. So let's try an example here. Let's go back. We did the Chinese zodiac before. Let's paste in an example using that again. Just put a BR tag here. I've defined the Chinese zodiac as a function. So here it is, Chinese zodiac. We pass in a year, and then it takes that year and does the same processing we did before. But now, instead of having assignment to a variable followed by break, instead now we're just going to return the value. That's it. So case 0, return rat. Done. No break required. And then let's jump down here and let's actually call our function. So let's say $zodiac is going to be equal to Chinese zodiac, and let's put in 2013 as the year. And then after we've done that, we'll echo back a string. 2013 is the year of the, and we'll put the zodiac here, and we'll end it with a period and a BR tag and a semicolon at the end. All right, so let's bring that up and try it. There it is. See how that works? Now we have a function that wraps up all of this logic for us. So now whenever we want to call this, we can just simply call it with a new number. Let's say that we're looking for 2027. 2027 is the year of the what? Goat. Now, we don't have to assign this to a variable here. Sometimes it's cleaner to do it that way, but I can do this inline as well. We can't do it with the curly quotes, but we can do it if we break those and use append, and then we can just put it right there. See how I've done that? Let me just widen my window a little bit. So I'm concatenating there. 2027 is the year of the, then call the function, and then the BR tags. Let's save it, go back and check that out. And there it is. It looks exactly the same. Now, by the way, I think it's a good practice to rarely have functions which output directly from inside the function. Now, that's what we've been doing before now as examples because we didn't know how to do return values yet. But most times I think it's better to build up text inside the function and assign that to a variable and then return the value of that variable at the end. Then we can echo that returned value if we want, or we can do something else with it. But it's better, I think, to leave echoes out of your function. So for example, we could redo our hello function that we had before. Right? We had better hello. Instead of echoing from inside that function, just change it to a return. Return that result, and now we can just as easily call echo better hello with hello, and then John Doe, followed by an exclamation point. Right? We can still call it that way. But see how much more flexible this is? We could take this and we could call upcase on it, or title case, or something else before we output it. We have more flexibility. So I think it's better to leave echo statements out of your functions and instead use return values. In the last movie, we learned how to return values from a function by using return. In this movie, we'll learn how to return multiple values from a function. Well, sort of. You see, a function can only return a single value. That's a hard and fast rule about functions, that it returns only a single value. So what if we need to return more than one value? Well, first let's create an example so we can look at the problem more closely. I'm going to open up basic.html and I'll do a save as on that. And I'm going to call this functions multiple returns.php. We'll give it the same name here, functions multiple returns. All right, let's start with a new function, and this function I've called add underscore subt, short for subtract. So it's going to add and subtract two values, value 1 and value 2. We're going to add them together, and then we're going to subtract them. So we know how to use return and how to return add, but how can we also return subt2? Let's just try this real quick and see. Let's go ahead and have result. It's going to be equal to add subt. Let's do 10, 5. All right, and then we'll echo back the result. All right, so let's just try this and see what we get. Let's go to Firefox, and instead of return values, we're going to go to multiple returns.php. All right, it gave me back 15. Now that's just the value of adding them together. It has nothing to do with subtracting. Now you might try, well, let's say what if we had a comma? Maybe you just do comma subt, save, go back, reload the page. Nope, parse error, unexpected comma. So it won't let us do that. It's nothing that is that simple. The problem is that functions only allow us to return one thing. So that's it. We're limited to one thing that we can return. So let's think for a second. We have two things that we want to return, but return will only let us pass back one thing. Is there a single PHP entity that will hold more than one entity? Yes, arrays. Arrays to the rescue. What we can do is return an array here instead. So array, and then add, comma, and subtract. There we go. All right, we'll remove that comment now. Now it will return an array. So what we're getting back here for result is an array. Just make that clear. This is result array. Now we don't want to just echo the result array anymore. We probably want to do something a little nicer. So let's do add, and then we'll concatenate that with result array 0 to get the first value. That's the add. And then we'll put BR tags at the end. And then let's do that same line again. Let's make the next one though subt. We'll make it result array 1. All right, let's save it. Let's go back and try that. And there we go. Add and subtract. We got both results back, and we did it by using this array as a vehicle to get more than one value back. And that's great because arrays can return a lot of stuff. So we can return 2 values, 3 values, 4 values. It's unlimited. We just have to wrap them up in this single structure, this single array, because that way that array can be our return value. Now, I don't know about you, but I think that this feels a little bit clunky to me. I really don't like the idea of having to write this in my code all the time, and this isn't very descriptive of what it does either. Fortunately, there's another better way to do it, and that is to use another PHP function called list. You use list to assign array values to variables. So for example, let's just copy all of this, and we'll drop down here, paste it in. This time though, let's just change it to add and subtract. We'll make it 20 and 7. And instead of result array, we're just going to say list, and then in parentheses, provide the variables that we want to use. I'll call this one add result, and I'll call this one subt result. All right, so that's what it does. It takes these values from the array, and it assigns them to add result and subt result. Then here, I can use those instead. It's a little less clunky. All right, let's just try that out. Reload the page, and there we go, 27 and 13. So I think list is super handy because it allows us to take all those elements that we just packaged up into an array to get out of the function and immediately break them back down, unpack it, and assign them to variables that have good common sense names that are easier to identify than something like result array 1. And the combination of the two, using array and list, is the best way to return multiple values out of your functions. We've seen how the variable names inside the function and outside the function are unrelated. When we wrote a function to do addition, the variable sum was only available inside the function. We couldn't use echo outside the function to retrieve that value. We had to use a return value instead. Having this division between the variables inside a function and outside a function is known as variable scope. A variable isn't accessible all the time. It's only accessible within its context. A variable created inside a function is by default only accessible in the function. We say that the function is the variable's scope. In PHP, there are two main scopes. There's the global scope and there's the local scope. Let's take a look at them so that we can see the difference. Let's start by taking basic.html, calling save as on it. We're going to call this functions underscore scope. And I'm going to end it with PHP. Save it. Now let's create ourselves a little example here. Let's call this functions scope. I'll start my PHP tags. And let's assign a value to bar equal to outside. This is going to be in the global scope. Now let's write a function. Function, we'll call it foo. And inside that function, let's once again set bar equal to, this time it'll be inside.
that is going to be local scope. All right, so now down here, let's echo 1 and concatenate that with the value of bar, followed by br tags. And there we go. And then we'll call the foo function. And then once again, we'll just echo back what var is, this time with the number 2 in front of it so that we can really see the difference. All right, clear what we're doing? We're looking at the value of bar, then we're calling the foo function, which is setting the value of bar, and then we're echoing it again. All right, let's try it. Let's see what we get. Let's go to Firefox, and instead of multiple returns, it's going to be functions underscore scope. Okay, they both returned outside to us. So this had no effect whatsoever. We did not set it to inside. And that's because this bar here is not the same as this bar here. Even though they have the same name, they have different scope. So it's actually a different variable as far as PHP is concerned. We can even test that further by going inside the function. And let's put a new line. Let's say if is set bar, then, and let's just do our echo here. We'll just paste it up here, but this time we'll do it from inside foo, right? So if it's set, then let's echo it inside the function. Let's take a look at what that looks like. See? Nothing came out because it wasn't set. Now, it doesn't even matter if we provide bar as an argument to foo, right? We've also got to have it down here. Let's send bar in. Now, this is the bar that was set here, right? That's what we're passing in. Think about what's going to happen, and then let's take a peek. Notice that it's outside all the way through. It still didn't change it, right? Because it got in here and it was local scope. When it exits the function, well, this bar right here, it's the same bar that we were working with before. The changes didn't stick because these changes were not to this variable. They were to the local variable, the local scope. Now, there is a way around this, though. There is a way for us to bring in the bar that's outside and to use it inside the function. If we go back to our house metaphor, it's like opening a window so that we do have access to it. And the way that we do that is by using the keyword global followed by bar. And I'm going to take this away. So we no longer have the argument anymore. Let's go ahead and leave this all in here. And now that we've declared it as being global, let's take a look at what happens. There we are. Did you see it change? So now it's outside. When we echo it the first time, we call the foo function, which brings in from the global scope bar. Then we have access to it. So now this bar, it's checking to see if it's set. That's the global one. That's the one up here that was outside. So that's what it outputs for foo. Then we set that same one equal to inside. When we leave the function, we're back in the global scope, but our global scoped variable is what changed. So that's why we get our third result as being inside. So global allows you to bring in globally scoped variables for use inside a local scope. Now use this with caution because you are affecting that global scope variable from somewhere deep inside a function. It's not immediately obvious to you when you call foo that that's what you're doing, that you might be changing some of these values, right? It's not very transparent and easy to see. You might be better off passing in a value than changing the value and catching the return value that comes out of it. That would be a lot clearer. And definitely don't use globals as a crutch or a way to keep from writing good code. In my opinion, you probably won't use more than 3, 4, or 5 variables that get declared as globals in most projects. It really is just some special cases of things that you need to bring in. Most of the time, you're going to want to use your arguments and return values instead. Now, even though you may never use that keyword global, what's most important is that you understand the difference between the two scopes and how they either interact or don't interact. We've already learned that the arguments when you call a function must match the arguments that were used to define the function. If you define it with 3 arguments, then you need to provide 3 arguments as input. However, there is a way around that by setting default argument values. Let's see how. So we'll open up basic.html and we'll call save as on that, and let's call this functions underscore defaults.php. Functions default argue
argument values. All right, so to start with, let's write ourselves a little function. And I'm going to call this function paint. All right, so function paint, and let me just put the curly braces there. And this paint is going to take a color as an argument. The work that this function is going to do is we're going to return a string, which is the color of the room is, and then we'll have our curly braces with the color, and then I'll put a period, a BR tag at the end, followed by the semicolon. Okay? So now we know how to call that, right? We can simply say echo paint and blue. All right, let's bring that up in a window and check it out. So here we go into Firefox, and now instead of function scope, we're going to be looking at defaults. The color of the room is blue, right? Makes sense. We have one argument defined, and we're passing in one thing. Now if we were to take blue away, then we'll get an error. It'll say, oops, sorry, missing argument 1 for paint, right? And then it also says undefined color here because we didn't pass anything in. So that won't work. We would need to pass in a placeholder, at least an empty string, something that it could work with. But if we use a default argument, the way that we do that is we do an assignment right after the argument. So we just do equals, and then let's put in a color here. So let's say that the color is going to be red. All right, so now let's just try this again. Reload. The color of the room is red. See what happens? It didn't get a value, so it gets here and it says color. And if you don't have a value for color, then go ahead and use red. We can have more than one of these. Let's add another one here. Let's say that we're going to have the room, and the room by default is going to be the office. We need a comma between those, right? So room equals office, comma, color equals red. So now we need to pass in two things. Let's also drop in the room here. So room, and then let's come back over here. The color of the office is red. Okay, I can also pass in something else. I could have bedroom and blue. I'll just leave my old one as well, just so that we still have that paint. You can see the difference. So now I'm going to use bedroom and blue, and you'll see that we get the default behavior followed by our custom behavior. See how that works? Now let's try one more. This time, instead of passing in blue, let's pass in null and see what happens. Go back here. The color of the bedroom is null. Even though it was null, right, we did not pick up this red value. It did not go to the default. We passed in something. That something happened to be null, but it was something. The defaults only take place if nothing fills that spot. And I don't mean nothing as in null. I mean no value gets sent at all. Don't let that trip you up. Not sending something and sending nothing are not the same thing. Now also, while it will work for you to just do bedroom and then provide nothing after it, right? The color of the bedroom is red. It picked up that value there. We can't do something like blue. Let's come back here, reload. The color of the blue is red. That's what we got back because we can't leave out this first one. The order still matters, and something has to hold that position. We can't put null here because we know what that would do. So something has to hold that. So because of that, you're going to want to make sure that any required values are going to be listed first. The optional ones, the ones that have defaults, need to be listed at the end of the argument list. Now the argument order doesn't matter to the function's operation. It doesn't care in what order they come in. As long as they match the way that it's called, it can sort it out. We can swap color and room, and it won't make any difference at all. But you would not want to do something like this, right? Here color is required, and room has a default value. Well, we've always got to provide something here. So this will never happen. We'll never get that office because something will always have to be provided here because this one is mandatory. That's all there is to working with default argument values. It's pretty simple to provide defaults, but there are some gotchas in there that can make it a little trickier than it first seems. Now that we have a lot of the PHP fundamentals under our belt, in this chapter we'll discuss ways to troubleshoot and debug your PHP code. And we'll start by looking at common problems, and then talk about the errors that PHP returns, and finally look at some debugging techniques. Let's start out by looking at the common problem. One of the most frustrating problems that you can run into is getting a web page that has no output on it at all. There's no real information there to go on. It just seems like the page is not working. The first thing you should do is try to access a basic HTML page. Forget about PHP for a second. Take it out of the equation. Make sure that your web server is running and that it's able to return HTML pages. That also helps to make sure that we're accessing the right directory in the file system that we think we are. Once we get that working, then we can bring PHP into the equation, and we can try to create a basic PHP page and see if we can get our web server to process the PHP. Remember that we have that PHP info function that we can use to drop into a simple PHP page. It will confirm that PHP is working, and it also gives us lots of configuration information that can be useful. Once we know that the web server is running, that it's finding files in the right place, that it can return those files, and that PHP is running, then the problem is probably in our code. You want to make sure that display errors is turned on and configured properly. We're going to talk more about that in the next movie. But you may be encountering an error and PHP just isn't showing you that error, so you're getting a blank page instead. Now let's talk about some of the common errors that you might have created in your code that would cause those errors. The first, and probably most common, is just simple typos. Maybe you just misspelled a variable name. Maybe you commented out something that you didn't mean to comment out. Typos are just a way of life when you're doing programming, and you're going to have to get used to combing over your code very carefully, very thoroughly, looking for mistakes that you've made. A very common mistake in PHP is missing the semicolon at the end of the line. Remember, those semicolons are super important. PHP is whitespace independent, so it doesn't matter if we have returns, but the semicolons are what tell PHP when one command ends and another one starts. It's also super common to have missing closing braces or missing closing quotes. And that would be that you open a parentheses, but you don't close it. Especially once you start nesting parentheses inside of parentheses, it can get hard to keep track. Most code text editors either helpfully add that other parentheses for you when you create the first one, but they will often also highlight the opening parentheses when you type a closing parentheses, so that it helps you know what that parentheses is paired up with, so you'll know when you have enough of them. Another problem can be from having case-sensitive variable names. Remember that something like myvar, all lowercase, and myvar with an uppercase V are two different variables. That's why I think it's a good practice to pick one style and stick with it. For me, that's why I like using all lowercase, so that I never have to run into this. All my variables are always lowercase. And then the last one that's super common, especially among beginners, is confusing equals with double equals. And I don't mean confusing in the fact that you don't know the difference, but that you mistakenly use the wrong one. So if you have a simple if statement, if I have count equals 3, well in this case I'm assigning the value 3 to count. So if count was equal to 10 when it got to this statement, and I was checking to see is count equal to 3, well guess what? Now it is equal to 3. I meant to be checking it, but instead I set it. Now these are the most common mistakes that people can make, but certainly there are a lot of other things that can go wrong. Remember that the php.net website is a great resource, and there's lots of documentation about how the different functions work, as well as helpful user comments below that that might be able to help you out with the problem you're having. And the PHP community is quite large, so there's all sorts of blogs and other documentation out there that you can search the internet and find that might help you to address your problem. When we encounter an error in our code, the more information that we have about that error, the easier it's going to be to resolve it. In this movie, we'll look at the warnings and errors that PHP generates and learn how they can help you to resolve problems. The first and most important thing is to make sure that error reporting is turned on. We can't deal with our errors if we can't see them. So we want to make sure that PHP is reporting errors as they happen to us when we're in development. There are two ways to do this. The first is that we can set the error reporting in the php.ini file. And we saw how to do that back in the configuration chapter. You just edit your php.ini file to have display errors on, error reporting equal to whatever settings we want to have for that, and then restart our web server so that it reloads that php.ini file. We can also set the error reporting on the fly in our PHP code. This is especially useful if we are working on a server where several people are sharing a copy of PHP. The php.ini file might not have the settings that we want customized for our little bit of code. So in that case, we can use the function iniset to set the value as if it had been set in the ini file. So I can set display errors to be turned on, and I can set error reporting using the error reporting function. Notice that on is the word on, it's a string, but error reporting is using a constant. e_all is a constant. It does not get quotes around it. There are a variety of values that we can provide to error reporting. A lot of those are detailed in the php.ini file or on php.net. Let's just look at a couple of them. One is that we can provide e_all and then an upright pipe followed by e_strict. What this is saying is we want all errors and also the strict errors. Strict is a category of errors that was added in PHP 5, but it wasn't incorporated into all until 5.4. So if you're using 5.4 and only 5.4, you can omit that second part and just have e_all. But if you're using 5.3 or anything before that, or if you're going to be moving back and forth, then you want to have both of them so that you're seeing all errors all the time. Now we don't have to see all errors. We can selectively turn off some errors. So if we wanted to turn off the errors that are regarding deprecated code, then we could have e_all, ampersand, and then the little twiddle followed by e_deprecated. Deprecated is a fancy word for code that has been scheduled for removal from PHP. So in the future, it's going to stop working. So I think it is generally a good idea for you to go ahead and have those errors in there so that you make sure that your code is forward compatible. And last, I just wanted to show you that you can return the current error reporting level by just calling error reporting with no argument. Now what it's going to return to you is a number. It's not going to return to you one of these constants. These constants all represent numbers, and it takes those and compiles them together into a single number that it will return back to you when you call error reporting. You can get that full list of numbers on the php.net website. There's a full list of all those constants and what numbers correspond to them. Let's take a quick peek. So here I am on that web page, and it has all the predefined constants here, starting with errors and logging at the top. And you can see here is the constant, and here's the value that corresponds to it. If you scroll down here to the bottom, you'll see here is e_all and the number that corresponds to it. What it does is it takes all of those numbers and adds them up in order to figure out what the current user level ought to be. It also gives you a description of what each of these error constants mean. This can be really useful when you want to configure your error reporting to report something less than all of the errors. Most times I think you probably just want to have it report all errors back to you though. And while this page lists off many different categories of errors, there's actually 4 main categories. Let's take a look at those and see what they mean. The first category of errors are fatal errors. What this means is that PHP understood what we were asking it to do, but it could not execute it. It'd be like if I asked you to walk from New York to London. You understood the English sentence that I just said. It made perfect sense, but you can't do it. When PHP encounters a fatal error, it is fatal for your code. It means that the page of code cannot be executed, and so you don't get back anything. It's essentially saying that PHP tried and gave up. The most common cause of a fatal error is going to be calling an undefined class or a function. If we try and call a function that hasn't been defined, obviously it can't do that for us. The second category of errors are going to be syntax errors. In this case, PHP just plain old couldn't understand what we were asking it to do. This is usually the result of a typo, a missing semicolon, a quotation mark, a parenthesis, something like that, something that makes our code not valid. It tried to parse it, it tried to figure out where one thing started and where one thing stopped, and it couldn't make any sense of it, and therefore it gives us a syntax error. Often these will be reported as a syntax error, and it will say unexpected something in this file at a certain point. It was expecting to get a closing parentheses, but instead it saw a call to define a function. Right? That was unexpected, and so it goes ahead and says, oops, that's a syntax error, something's wrong here. After the error, it will also tell you what file the error was in and the line number where the error was encountered. It's helpful if in your text editor you turn on line numbering so that you see the line numbers running down the left side. That'll help you identify the line very quickly. It's also very common with syntax errors for the line number to be off by 1, because if it encountered an unexpected something, the problem is probably that something happened right before it that caused it to be unexpected. The next category are warnings. This indicates that PHP found a problem, but it was able to recover from it. It was non-fatal. It understood what you were asking, it was able to execute it, but it ran into a bump along the way. It indicates that you probably made a mistake and have a bug in your code. It wasn't a fatal error, but the page is probably not correct. It's probably not what you intended. An example of a warning would be if you try to divide by 0. It'll come up and give you a warning that you can't divide by 0. It'll keep processing everything after that, but whatever that mathematical operation was will have failed. You'll also get warnings if you have the incorrect number of arguments sent to a function, or if you have the incorrect path to a file, or if you don't have access permissions to access a file. And the last category are notices. Notices are just PHP offering you advice. Think of it as PHP telling you that something smells bad. It's a good indicator of bugs and sloppy programming style, and it can also include those deprecation notices that tell you about code that's scheduled to stop working in future versions of PHP. Your code is fine, but you really ought to think about making these adjustments. If you were going to turn off one of these 4 categories in development, notices is probably the one that would go first. Now, as I said at the beginning, we want to make sure that we do see these errors and warnings when we're in development. It's tremendously helpful for identifying problems. However, we do not want to have errors displayed when we launch our website to the world. First of all, they're ugly. And second, it would be a major security failure. It would reveal far too much detail about our code. So you want to make sure that you turn off error reporting when you launch your website to the world. But just because those errors aren't on the screen anymore doesn't mean that they don't exist. Errors and notices are still generated by PHP whether they're displayed or not. And it's important to note that that takes up some time. So if you have lots of those pesky little notices that have been generated, well, if you deploy with that, PHP is still generating those notices, and it does have an impact on performance of your website. So it is better to go ahead and address them and fix them. Even if they're just notices about deprecations, go ahead and fix them now to speed up your website. The second point is that chances are those errors are still being logged by your web server. And that's good, because we definitely want to know about those errors that our users are getting on the live site. In fact, it's as important, if not more important, to know about problems that are happening on the live site than it is to find out about errors that are happening when we're developing. Now, where your web server logs those errors can vary and can be configured, but I want to give you just a few of the places that you might look for it. If you're on Mac OS X, chances are that by default it's going to be logging to private var log Apache 2 error log, and that's where you would find it. If you're on Windows and WAMP, chances are it's going to log into the WAMP folder, into logs, into php_error.log. Or you can access those logs from the WAMP menu. If you're running Apache, well then it's probably being configured inside Apache's config file, and you could look there to find out where that's being stored. If you look in there, you do a search for log, it should tell you where the log file is being stored. And if your version of Apache is loading in other configuration files, let's say different files for different domains that are hosted on the same server, well then those might be the place to configure where the error logging occurs. You want to make sure that you check these error logs from time to time, otherwise you won't know what problems your users are encountering. In the last movie, we looked at the warnings and errors that PHP generates. But often we need to debug our code even when we aren't getting a PHP error. We just aren't getting the results that we expected from our code. Maybe a condition that uses less than ought to be using less than or equal to. Or maybe we put code outside of a loop that ought to be inside the loop. As with errors, the more information we have about a problem, the easier it'll be to solve it. And the best way for us to get more information is to output that information to the HTML page as our code is running. Now sure, this extra output is going to make the page ugly while we're debugging, but that's okay because we're not planning to keep it. It's just temporary. There are a number of ways we can output useful information, and we've seen 3 of them already. The first one is super simple. We just echo the value of a variable. If you're wondering what the value of x is each time it goes through a loop, just right in the middle of that loop, echo out the value of x. We'll see it on the page, and we can watch the value change with each iteration of the loop. Echo is also going to be super helpful when we start working with databases, because we're going to assemble SQL statements in a variable and then send that statement off to the database. If we don't get back the results from the database that we expected, we can echo that statement and see what was the SQL statement that we had constructed, and we can examine it for errors. The second one we've already seen is print_r. Remember, that's for printing a readable array. Works with arrays and makes them output in a much more user-friendly way. Remember that this is going to look best if we surround it with HTML pre-tags. That will allow it to preserve the white space and make the formatting even nicer. The third one we've seen before is getType, and that just returns the type of a variable. Maybe we're working with a string when we ought to be working with an integer. Well, getType can help us to identify that. There's also some new ones that we should look at, the first of which is var_dump, and that's going to take everything that it knows about a variable and just dump it out for you. It's going to return the value. It's also going to return the type, and if it's an array, it's going to give you a nice friendly output of that array. It's essentially doing what all 3 of the functions up above it do. It's extremely useful, and I think you're going to find that you use it a lot. The next one you should know about is get_defined_vars, and that's going to return an array of all of the defined variables that PHP knows about at that moment. Now that's not just the variables that you've defined, it's going to include a few other special variables that PHP uses. But that's good, it's going to show us everything that PHP knows about variables. Another very helpful one is debug backtrace, and that's going to show you a backtrace. It's going to return it as an array. A backtrace, also called a stack trace, is a report of the function calls that have been made that lead up to a certain point in time during the execution of a program. It's like a report of what happened before you got to where you are now. Backtrace as in retrace your steps backwards. Let's try some of these. So I'm just going to open up basic.html, and we'll do save as. We'll call this debugging.php. Change the title to debugging, and I'll create my PHP tags, And I'm just going to assign a couple of variables here. I've got number equal to 99, string equal to bug question mark, and array equal to an associative array. So I've got keys and values there. So let's try this var dump. We won't try the first three because we've already used those before, but let's start with var dump, and let's just do var dump and $number. Let's go try that out in a browser. Localhost, and for me that's going to be at Kevin Skogland, sandbox, debugging.php. And there you go. I got back int 99. It's telling me it's an integer and the value is 99. I even got some nice color formatting on that. Let's go try the next one now. Just copy this and paste it, and we'll change it from number to string. Let's take a look at what that does. String, here's the value, and it tells me the length of it. Nice little added bonus there. And let's try one more. We'll try it with array. Save it. There we go. See how it gives me a nicely formatted array? I didn't even have to use pre-tags around it. It went ahead and just said, here's the array. There are 3 elements in the array. That's its size. Here they are. 1, 2, and 3 are the keys. Here's the values. And it went ahead and further broke down that value and said that value is a string. Here's the value of the string, and here's the length of the string, just like it did up here for this one. So you can see that's super useful, right? Let's take a look at another one. Notice that the var dump actually did the output. We didn't need to say echo or anything like that. It dumped it to the screen. That's what it does. Now we're going to take a look at get defined vars. So let's do PHP and get defined vars. And let's just do that, and we'll reload the page. And you'll see we got nothing back. Why is that? Well, it's because what it does is it returns an array. Put a BR tag in here. So we need to echo that out, but it's an array. So there's no point in using echo. We could use print r, and that would work. And remember that print r looks best when we surround it with pre-tags. Let's come over here and try that out. And here we go. It's a long list. You see there's lots of these that are things that we didn't set, but if you scroll down here to the bottom, you'll see here's number, string, and array, and here's those values for us. So that can be useful to find out a lot about the variables that PHP knows about. Because that's so long right now, I'm just going to comment that out. And then we'll move on down to the next one, because I want us to try out this backtrace. Now debug backtrace also does not output, it just returns an array to us. So let's go ahead PHP, but this time instead of using print r, I'm going to use var dump debug backtrace, all one word. So let's just try that and see what that gives us. And here we are, array size 0 empty. That's what it gave us. Well, if you think back to what I told you about debug backtrace, it's a report of the function calls that have been made that lead up to a certain point in time. Well, we haven't made any function calls here, so we need to do that. We need to have a function call. I'm just going to bring up one of the functions that we've worked with before, and that is the say hello to. Say hello to word, remember this just outputs everyone. So let's just bring that up so we can see it first of all. Hello everyone, that's what it does. All right, so let's say that we're in the middle of debugging this and there's a problem. We can just do a debug backtrace right here. So let's do var dump and then debug backtrace. So we'll do it right after that line, and then we'll hit return. You'll see that it comes back and it tells us, here we are, the array size 4, and it has the file that we're working in. See, it lists where the file is located. It lists off the line number. So line number 33 is where we are. And the function that we're inside of. We're inside the say hello to function. And then the arguments that have been passed in, it also tells us, and that's an array. And everyone was the string that was passed in. So we get all sorts of useful information from inside that function. And if we have several functions, we have functions inside of functions or files that are calling other files, it'll trace it step backwards through all of those and show you all of them. It can be very, very useful. Now, PHP does not have an official internal debugger. Some software programs do have a debugger built into you that can help you debug things. But there are a couple of third-party tools that are worth knowing about. The first of these is Xdebug. And Xdebug is probably the most popular debugger for PHP. It offers things like showing you that stack trace whenever you have an error automatically. It logs all of the calls to your functions. It will make your var dump output look even prettier. All sorts of things like that it'll do for you. It's a really nice companion to have. Another alternative is DBG. You can go to their website and look up more information about that. And then the last one is fire.php. And this uses Firebug for Firefox. So if you're familiar with Firebug, it's a useful, popular add-on to the Firefox web browser that gives you more information about what's happening on a web page. And FirePHP enables you to log debug information to your Firebug console from your PHP application. So that can also be really useful. Now, as I said at the beginning, this kind of debug code is a temporary measure. It's meant to only be there while we solve the problem. Once we're done solving the problem, we want to make sure that we remove that code so that it doesn't accidentally end up in our application permanently.